Tonight, we begin at home, a quiet world turning through darkness, a thin line of dawn climbing the curve of a blue horizon, city lights fading like embers under morning clouds. The oceans hold their breath. Somewhere, a train crosses a river. Somewhere, a child rolls over in sleep. You are here, in a room, on a street, in a town with a name, on a world with oceans and weather, and a moon that pulls at the tides like a patient hand. Your lungs rise and fall. The clock on the wall blinks forward by a single second. Nothing feels cosmic about it. It feels ordinary, safe. Let's zoom out together, slowly, gently. First, the room loosens its hold. Ceiling, walls, the small echo of your breath. We rise through the roof as if it were fog. The town unfolds. Warm windows, a late car turning, a dog lifting its head and then settling again. Streetlights draw lines through damp air. A river glints like a seam of metal where the last streetlight touches it. Higher. Clouds. The familiar shapes you've guessed at since childhood. Dragons, ships, saints, now becoming soft planes of light. Lightning flickers far away. Too slow and quiet to fear. The planet's weather is a skin of moving thought, and we pass through it like a quiet idea. Higher still, the curve appears. That first gasp, the line of the world against black space, the faint ribbon of air that keeps water liquid and skin warm and stories possible. Look at that pale rim, the atmosphere, no thicker in all that scale than a breath on cold glass. You live beneath that veil. Everyone you have ever loved has lived beneath that veil. It is almost nothing. It is everything. Night and day share the globe, like two hands cupped around a candle. On the night side, cities glow like constellations trying to be heard. On the day side, white storms walk across the Pacific. The Sahara is a curve of bronze. Greenland holds a quiet bruise of ice. Listen, the planet hums. Oceans pull at the moon, and the moon pulls back. The iron heart turns, and the magnetic field wraps us in an unseen cloak, deflecting angry particles hurled from the sun. The shield is silent. You never hear it work, but it works. It has always worked. And because it works, you can sleep. We rise. The moon appears, not as a symbol, not as a word, but as a place. Scored with impacts, plains of frozen lava, a horizon that comes too close. The distance between Earth and Moon could hold all the world's continents laid end to end, with room to spare. You could stack every airplane you've ever flown and never reach halfway. It looks near. It is not. The moon tugs. Oceans breathe in and out. Tides mark the coasts with a slow heartbeat, older than cities, older than history. Lovers time their promises to its phases. Wolves time their songs. Farmers once timed their harvests. Tonight, it is just a white coin, drifting, a clock face without numbers. Patient. We zoom again. Earth becomes a bead of blue and white, threaded to a star. The sun is not. A hole of light in the sky. It is a sphere of nuclear fire large enough to swallow 1,000,000 Earths. It looks warm. It is violence contained by balance, gravity holding fusion in a long, bright truce. Every blade of grass on every field, every apple, every leaf lit in a kitchen window, paid for by the sun's burning. The light that touches your wrist tonight left that star 8 minutes ago, crossed 93 million miles, and then rested on your skin as if it had always meant to. We float outward through the inner worlds, Mercury, scorched, airless, the sun too close like a god that won't look away. Venus, clouds thick as stone, an atmosphere that crushes and cooks and never forgives. Mars, quiet plains, old river paths, polar caps that blush in spring, and dust devils drawing writing that no one reads. Between Mars and Jupiter, rocks wander, the asteroid belt, like the rubble of a grand building that never quite stood. Some pieces are mountains, some are cities. Each is a book without pages, holding a history written in impact scars and frozen minerals. We pass them without sound. Even the stories here are silent. Now Jupiter. We do not approach. We are approached. A world of storms, so large that 1,000 Earths could disappear inside without a splash. The great red spot is an old, tired hurricane, older than telescopes, older than the word hurricane. Moons drift like lanterns. Io, bright and volcanic, reshaping itself in lava. Europa, smooth and quiet, hiding an ocean deep enough to drown all the oceans of Earth and more. An ocean in darkness, possibly warmed by tidal kneading, possibly listening. Ganymede, Callisto, names that sound like music boxes. Worlds that are not stages for us, but stages in their own right. Saturn arrives with grace. The rings look solid, like the grooves of a god's record. But they are ice and stone, pieces the size of mountains, the size of houses, the size of snow. Each follows its own path, and together they form a sheet so thin it almost isn't there. A geometry drawn in gravity and patience. You could stand on a moon of Saturn and see the rings stretch like a road around the planet, and think, without embarrassment, that the universe made something just to be beautiful. Farther. The light thins. Uranus turns on its side, like a sleeping whale. Neptune sings in winds that would shred a city to chalk. Past them, a border only we named. Kuiper Belt, scattered ice, lost comets dreaming of long ellipses that will one day bring them near the sun for a single, bright moment, and then back to cold for centuries. The solar system does not end here. It fades. The sun's breath reaches outward in a bubble. The heliosphere, pushing back the interstellar wind in a shape like a teardrop. The edge is not a wall, it's a hush. At last, the sunlight weakens to memory. We turn back for a moment. The home star is a spark in black water, and you, a person in a room, are connected to it by a line. No, one can see. A line of light. By the time that line reaches the edge where we hover, it is thin as rumor, but still, it reaches. Now we loosen our hands and drift into the neighborhood between stars. Space is not empty. It is thin. A few atoms in a room the size of a house. A handful of dust in a cathedral. Yet even thin things can hold shape over distance. Clouds of gas stretch for light years. Great ragged sails of hydrogen and helium, patched with carbon, oxygen, iron made in the throats of dead stars. Somewhere inside those clouds, turbulence braids matter into knots, and gravity whispers, "Come closer." It always whispers that. And in time, the knots become warm. Warm becomes bright. Bright becomes stars. Our nearest neighbors flicker into notice. Proxima Centauri, small and red. Alpha Centauri A and B, a pair that dance around a shared point, like skaters who refuse to let go. From there, the distances begin to mock our senses. A number like 4 light years feels almost manageable, until you understand what light year means. Not time, but distance. Trillions upon trillions of kilometers measured by the fastest thing that can exist, and still taking years to cross. We keep our pace soft. We are not racing, we are noticing. As we rise again, the familiar pattern of our galaxy grows from a scatter into a promise. A barred spiral with sweeping arms, a bright core, dust lanes like fingerprints. The Milky Way is not a smear on the sky anymore. It is a city with 200 to 400 billion lights, and each light is a sun, and around many of those suns are worlds, and on some of those worlds there are seas, and under some of those seas there are vents that breathe chemicals into dark water, and around some of those vents are cells trying to organize hunger into a plane. Perhaps Perhaps in 10,000 places, perhaps in none. We do not know, and the not knowing is not frightening tonight. It is a soft, open door. We pass above the galactic plane, look down, see the spiral arms curling like the wake of a slow ship, see the dark rivers of dust where stars are born, and the bright clusters where young suns still shout about it. In the center, a black hole holds court, a supermassive silence, 4 million times the mass of our sun. It is not a vacuum cleaner. It is a geometry, space-time bent so deeply that even light, which usually refuses to bow, does not return once it crosses the horizon. The galaxy understands this and orbits accordingly. No panic, just law. Farther, the local group spreads out like a small family at a long table. The Milky Way, Andromeda, the Triangulum Galaxy, and dozens of dwarfs, like polite cousins. Andromeda drifts toward us at about 110 kilometers per second, which sounds urgent until you remember the table is 2 million light-years wide. In 4 billion years, we will meet. The two spirals will pluck at each other's arms, tear clouds into ribbons, light the sky with newborn star clusters, and then settle into a single new shape. If there is anyone on any shore, then they will look up at a sky that looks like a painting that forgot to end. No one alive tonight will see it. That fact is less sad when you are this far out. Time is different here. It moves like weather. We climb until superclusters appear. Laniakea, our address in the greater web. Galaxies threading into filaments, filaments crossing at nodes, nodes framing voids as wide as thought. The pattern is not perfect. It is rough, like woven wool. But order hides inside the roughness. Gravity gathers, expansion stretches. Between them, structure. And now, as gently as a breath leaving the chest, we reach the limit of what light can currently tell us. Not the edge of the universe, there may be no edge, but the edge of the observable, the farthest places whose light has had time to arrive since the beginning. The cosmic microwave background is a fossil glow, thin and uniform with small ripples that became everything. You could call it the first photograph. You could call it the first lullaby. Here is where the mind wants to ask big, sharp questions. What is beyond this? What was before that? Is there a before? Did time itself bloom with the first light, like a flower that knows only opening? Tonight we do not press. We are guests. We stand quietly in a museum where the exhibits are distances and the labels are numbers that only pretend to explain. We turn and we begin the homeward glide. The return is always faster. Not because distance shrinks, but because familiarity does what it always does, makes the vast feel held. Superclusters thin to clusters. Clusters resolve to galaxies. Our spiral finds its shape again. The bar, the arms, the dark lanes, the center's quiet pull, the halo of old stars that have forgotten most of their stories. We slip back toward the Orion arm, toward a little spur called the local spur, toward a place where a small star turns and warms a small world that never feels small when you are on it. Past Neptune's blue hush, past Saturn's bright rings, past the thunder of Jupiter, past the tender rust of Mars, past the hot stone of Venus, past the quicksilver of Mercury. The sun swells back from spark to god, to neighbor to lamp. The moon grows from coin to companion. The atmosphere's thin ribbon glows again around Earth, like a promise kept. We hover once more above the night side. There, do you see it? Your country, your river, your city, your street, the window that knows your shape in silhouette. No trumpets, no revelation, only the quiet fact that after all that distance, you have a place to land, a bed, a pillow that remembers you, a body that belongs to gravity and to time, and to 100 atoms forged in ancient stars. You inhale. The planet exhales. The window gathers a faint film of your breath and lets it fade. Tonight, let the scale comfort you, not crush you. Let the numbers be soft, the distances a quilt. You are small, yes, but never separate. The light on your wrist left the sun 8 minutes ago, but the iron in your blood left a star before the earth had oceans. The calcium in your bones is sea talk, hardened into cathedral. The oxygen in your breath was knitted by leaves and set free by fire. You are a local expression of a wide law. You're a quiet note in a long song. You are home. Close your eyes. The room returns. The house settles. Somewhere, a train crosses a river. Somewhere, a child rolls over in sleep. We will go farther next time. For now, rest. We return to the quiet blue world. Night folds around it like a blanket stitched with city lights. Out there, one companion keeps watch, the moon. It is easy to forget that it moves. From a window it looks fixed, patient, loyal, but it is gliding away from us, about 4 centimeters each year. Slowly, silently, it is leaving. If you could live long enough, you would see the nights grow a little dimmer, the tides a little weaker, the day a little longer. Time itself bends under that retreat. Look at it now, not as a circle painted on darkness, but as a world, real, scarred, old. Its light is not its own. It is sunlight, borrowed and returned with softness. The same light that warmed your hand 8 minutes ago now bounces off gray dust and finds your face again. Everything in the sky is a reflection of something else. Zoom closer. The surface is a frozen storybook of violence. Every crater is an echo of an encounter. Some impacts were so fierce they splashed molten rock hundreds of kilometers away, leaving glass beads that still sparkle under astronauts' boots. The moon remembers everything. It has no wind to forget, no rain to forgive. Once it was closer, much closer. The earth spun fast then. Days were 5 hours long, and the tides climbed continents like restless giants. Those tides tugged at rock and ocean alike, pulling energy from rotation, slowing the planet's spin, pushing the moon outward. This dance has never stopped. The moon slows Earth. Earth throws the moon away. It is not rejection. It is balance. On our shores, that gravitational whisper still shapes life. Tides breathe in and out. Coral reefs time their spawning. Crabs march by lunar clock. Even our words, month, menstruation, lunatic, carry traces of the moon's rhythm. We built calendars around it before we learned to measure years by the sun. Every ritual fire, every agricultural hope, once lifted eyes to that bright wound in the sky and took instruction from its phases. Imagine the first humans who noticed its pattern, waxing, full, waning, gone. The first reliable cycle in a chaotic world, when everything else seemed wild, storms, hunger, death. The moon came back. Faith might have begun right there, not in gods, but in return. Its pull does more than raise oceans. It steadies Earth's tilt, keeping our seasons gentle. Without it, the planet would wobble like a slowing top. Ice ages would come and go with cruel rhythm. The moon is the reason. Strawberries have a season and snow remembers when to fall. It is the metronome of life's tempo. Listen carefully. The tides you hear at a beach are not just water moving. They are time made audible. Each wave is an echo of that first collision when the moon was born, from Earth itself, torn out by an ancient impact so immense that the sky would have glowed red for centuries. You are looking, always, at a piece of Earth that escaped but never quite left. Now picture standing there, on the surface, no air, no sound, The horizon only a few kilometers away, curving too soon, giving everything a claustrophobic intimacy. The sun hangs brutal and sharp. Shadows are pure black. You look up, and Earth fills half the sky. Blue, white, alive. You can see weather. You can see the shimmer of oceans. You can almost hear rain. It is the most beautiful thing any eye has ever seen. And it is home. Back down on Earth, we follow the moon's slow story. Every rise in the east, every setting in the west, every eclipse where shadow and light trade places. These are chapters of the same book. When the moon covers the sun, midday becomes ancient night. Animals fall silent. People look up. For a few minutes, the modern world remembers how to feel awe without irony. Through telescopes, through poetry, through tides pulling at our sleep, the moon has never stopped teaching us perspective. It reminds us that motion can be slow, and slow can still be power. That silence can rule a planet's rhythm. That distance can nurture connection. Tonight, when you see it outside your window, remember this. Its glow is 8 minutes plus 1 second old. Its orbit is widening by 4 centimeters. Its influence turns every drop of your blood a little toward the sea. You are, in the smallest measurable way, moved by the moon. Breathe with it. In, out, tide, return. Next we'll drift outward again, to meet the rest of the family around the sun, the inner planets, and their hidden harmonies. But for now, stay here, watching that pale companion slide across the dark. It has been following you all your life. The sun waits at the center, a patient furnace. Around it, a handful of worlds turn in quiet choreography, each with its own tempo, each singing a different verse of the same cosmic hymn. Tonight, we drift from one to the next. No hurry, only light and motion. Mercury closest to the fire, a scarred marble locked in daylight and darkness. One side burns at 700 degrees, the other freezes near absolute zero. There is no air to carry sound, no sky to soften the light. If you stood there, the sun would look 3 times larger than from Earth. Too near, too white. Mercury spins slowly, orbits quickly. Its year lasts 88 days. Its day lasts nearly twice that. Time folds strangely here. The horizon blazes, then cools into silence, then blazes again. It is a world of extremes, no storms, no water, no mercy. Yet even this place has beauty. Cliffs, hundreds of kilometers long, carved when the planet's heart shrank as it cooled. Every wrinkle is the memory of contraction, a world pulling itself inward, the way an old tree draws its rings tight. Venus a mirror in the sky, beautiful from afar, cruel up close. Its clouds are sulfur and acid. Its surface pressure could crush a submarine. Temperatures melt lead. Rain never reaches the ground. And yet, in its thick golden atmosphere, sunlight turns to amber glow. Wind sculpts patterns like silk waves around the planet. From orbit, it looks serene, an endless sunrise frozen in place. We call it our sister, but it is more like a warning, a world that once might have had oceans, maybe life until greenhouse heat ran wild. If Earth ever forgets humility, Venus is the ghost that will remind it. Earth home, the quiet blue heartbeat in all this dark. We know its continents, its salt, its smell after rain. But from out here, you see only pattern, swirls of white cloud over blue, brown, and green. No borders, no nations, only one breathing surface. The others spin for physics. Earth spins for life. Everything that crawls or flies or dreams does so because this small world learned how to balance chaos and calm. It learned to make oceans, to make weather, to make us. Mars a desert dream, rust-colored plains under a salmon sky, dust storms that can swallow a hemisphere, mountains higher than any on Earth. a canyon system so long it could stretch across the United States and never end. Once, rivers ran here. We've seen their ghost beds, dry deltas, channels, flood fans, ice hides under the soil, maybe microbes still whisper beneath it, asleep for 1 billion years, waiting for warmth. To look at Mars is to look at a photograph of Earth's future, cold, dry, tired, but still red with memory. Someday we may build small domes here, small gardens, small hopes. The planet will watch quietly, the way old things do when youth tries again. The asteroid belt. Not a wall, not a ring, but a scattered family. Thousands of fragments between Mars and Jupiter, shards of a world that never was. They move like old dancers who know each other's steps. Some are bright with metal, some are black with carbon. We pass through them as sunlight blinks across their surfaces. Each one spins in solitude, yet together they form a boundary, a transition, a kind of cosmic pause before the giants begin. Jupiter, the king. A storm world so immense that it guards the rest of the system from ruin. Comets that might have struck Earth are caught in its gravity and swallowed whole. The great red spot turns endlessly, a storm older than every country we know. Inside that maelstrom, winds race faster than any hurricane on Earth, yet it has held its shape for centuries. Around Jupiter dance its moons, a miniature solar system. Io, volcanic and violent. Europa, with its secret ocean under ice. Ganymede, the largest moon in the system, carrying its own magnetic field. Callisto, cratered and quiet. Each could be a world. Each could hold stories we haven't heard yet. Jupiter hums in radio frequencies. If you could listen, it would sound like deep static, like the breathing of a god, half asleep. Saturn grace, embodied. Rings of ice and dust. Thin as a whisper, wide as 1,000,000 kilometers. They shimmer because sunlight loves them, each particle catching a different hue. The planet beneath is pale gold, streaked with storms that rise and fade like sighs. Moons orbit everywhere, Titan with its thick orange sky and methane lakes, Enceladus spraying water into space like a broken fountain. Where that water falls back, it writes poetry in frost. Saturn doesn't shout. It glides. Even its storms look polite. Uranus, a world that forgot the rules. It rolls on its side, poles where equator should be. Seasons last decades. Its blue comes from methane. Its winds blow sideways. There's a hush about it, as if it wants no attention. Voyager passed once, looked back, and it seemed almost shy, a turquoise pearl turning slowly in darkness. Neptune, last of the giants, deep blue, restless. Winds tear across its surface faster than sound. It radiates more heat than it receives, like a quiet furnace that refuses to go out. Its largest moon, Triton, orbits backward, hinting that it was captured, not born here. Volcanoes of ice and nitrogen rise from its surface. Plumes fall back as snow that would cut you like glass. At this distance, sunlight is a pale memory. If you stood on Triton and looked toward the sun, it would be just another bright star. And beyond Neptune, the frontier fades. Pluto, Eris, Sedna, the Kuiper Belt, the Oort cloud, and then interstellar night. The sun's family ends not with a wall, but with distance. Every planet, every moon, every rock carries a version of the same lesson: motion, balance, impermanence. Some burn, some freeze, some hold seas, some hold silence. Together they orbit one light, one rhythm, one origin. And somewhere on the third planet, under clouds and wind, someone looks up and whispers, "We are part of that." We have drifted past Neptune's blue edge. Now the sun shrinks behind us. No longer a blazing god, only a bright coin lost in velvet distance. The warmth that once filled your childhood sky is now a memory that takes hours to arrive. We enter the interstellar sea. The space between stars is not empty. It is a hush filled with ghosts of atoms, hydrogen, helium, dust no heavier than thought. Each grain carries a story, carbon born in one supernova, iron from another. The debris of every dead star becomes the soil for the next. Even here, creation hides inside ruin. After a long silence, a faint red glow rises ahead. Proxima Centauri, our nearest neighbor, 484 light-years away. To light, that is a 4-year walk. To us, it is eternity. It is small, faint, restless, a red dwarf that flares without warning. Planets cling to it, some perhaps close enough for warmth, but every orbit is a compromise between freezing night and sterilizing fire. If life exists there, it has learned endurance as its first language. Proxima is part of a trio. Alpha Centauri A and B, two sun-like stars circling one another in a slow dance. From far away, they look like a single point, but if you were there, you'd see dawns with twin shadows, two suns rising and setting at opposite ends of the sky. Their light would tint the air gold, then copper, then rose. It would feel like living inside a perpetual sunset. Between these stars stretches darkness deeper than any ocean. Yet even darkness here has structure. Rivers of charged particles, magnetic fields twisting like unseen ropes, comet trails wandering for millions of years. The neighborhood is full of drifters, rogue planets kicked from their birth systems, dust spirals from dead suns, tiny icy bodies carrying amino acids, the alphabet of biology, through the dark. If you listen closely, you can almost hear motion, like wind against a distant hull. Our sun and its companions belong to a local assembly, about a few dozen stars moving roughly the same way, bound not by friendship, but by the gravity of the Milky Way. We travel together through the galactic arm, like a slow caravan crossing a desert of time. Every 230 million years, the sun completes a single lap around the galaxy. Since the first dinosaurs looked up, we have barely rounded a fraction of that orbit. Civilizations rise and vanish while the stars continue their silent march. Somewhere out there lies Barnard's star, older than the sun, moving fast across our sky, and Wolf 359, faint, almost invisible, but glowing faithfully in radio wavelengths. Each one is a lighthouse you cannot see with your eyes, but the instruments we build can hear their whispers, simple pulses that say, "I am still here." When you think of a neighborhood, you picture fences, lights, perhaps voices behind windows. Out here, the fences are gravity wells, the lights are fusion, and the voices are radiation murmurs that take years to arrive. Yet the feeling is the same. We are not alone, just far apart. Now drift a little farther. The sun becomes one of many dots in a soft smear called the local bubble, a cavity in the interstellar medium carved by ancient supernova. Its walls are faintly glowing gas, its interior relatively clear. We live inside that bubble, in its calm center, like a town resting in the eye of a storm that happened 1,000,000 years ago. Every star around us sparkles through the thin mist those explosions left behind. Even destruction can make clarity. Ahead lies the next frontier, the pattern of the Milky Way itself, a spiral of hundreds of billions of suns, each with its own neighborhood, its own stories, its own people, perhaps wondering who else is out there. Hold this thought before we go. Between here and the next nearest star, there are 40 trillion kilometers of silence. And in that silence float the same elements that built your body. When you breathe, A few of those atoms once drifted here before being swept into Earth's air. You have already shared matter with the stars you've never seen. We are no longer in a neighborhood. We are in a city, vast beyond arithmetic, luminous beyond mercy, a barred spiral galaxy called the Milky Way, 100,000 light-years wide, spinning like a slow pinwheel stitched from light and dust. Everything you've ever known lives inside one narrow arm of this Leviathan. Your sun, every comet and whisper of Voyager 1, floats in a thin river of stars called the Orion Spur, a side street between two grand avenues, Sagittarius and Perseus. We are, cosmically speaking, not downtown, just comfortable suburbs on the inner rim of greatness. The shape of light from Earth, the Milky Way, looks like a faint cloud. Step away from city glow and you'll see it. A pale river crossing the night, dense and uneven. But that river is not a band painted across the sky. It's the cross-section of our own galaxy seen from inside, the way you might see the blur of a forest when standing among its trunks. If you could step outside and look back, you'd see a glowing disk 10 times wider than it is thick, and in the middle, a bright bar of stars, the core, rotating like the hub of a wheel. The disk spins once every 230 million years. When the first mammals blinked in volcanic twilight, we were somewhere near where we are now. When the last dinosaurs fell, we had barely drifted a few degrees along our galactic path. Human history, all of it, is less than a heartbeat of this rotation. The dust between stars. What gives the Milky Way its beauty is not just the light, but the shadows, veins of interstellar dust, dark as smoke, coiling through its arms. That dust is carbon and silicate, the ashes of long-dead stars, ground fine by time. In those clouds, new stars are born. Gravity gathers the dust, pressure heats it, hydrogen ignites. Each newborn star bursts through its cradle with ultraviolet light, carving holes in the very clouds that birthed it. Creation and erosion share a single gesture. If you could sail through one of these nebulae, it would not look like the colored photographs. Those hues are long exposures translated for human eyes. In person, the glow would be subtle. Faint greens, soft violets, ghost blue. You would feel the radiation more than see it, like a hum against the bones. Somewhere in the Carina arm lies the Eta Carinae Nebula, home to a pair of colossal stars dancing toward mutual destruction. Their outbursts sculpt wings of gas 50 light-years wide. When one finally dies, it will light up half the sky. For a moment, our city will notice its own heartbeat. The crowd we live in. There are between 200 billion and 400 billion stars in this spiral. Even if you counted one every second, you would die before finishing the list. And by then the galaxy would have moved. The count already wrong. Many stars have planets. Perhaps half have systems. Perhaps billions of those worlds wear atmospheres. Some are scorched deserts. Some may carry oceans under ice. Some may cradle cities whispering to the dark, asking the same questions we do. Yet despite the numbers, space between stars is enormous. If the sun were a grain of sand, the nearest star would be another grain 4 kilometers away. Between them, nothing you could touch, only probability and patience. The core. Let's travel inward. The star density thickens. Night becomes a field of diamonds. Here lies the galactic bulge, a sphere of ancient suns orbiting the center like bees around a hidden queen. At the core waits Sagittarius H, a supermassive black hole, about 4 million times the mass of our sun. It is invisible, yet the stars near it move as if haunted, whipping around an unseen point at thousands of kilometers per second. That is how we know it's there. Gravity leaves fingerprints even when light cannot. Black holes are not holes. They are places where space folds so tightly it points inward. Cross the event horizon, and every path leads deeper. Not even light can climb back. Yet paradoxically, the violence around them creates brilliance. Matter spiraling in becomes a shining disk, hotter than any star. Even absence can glow when fed. Astronomers once captured an image of Sagittarius A, a ring of fire blurred by distance and dust, a portrait of gravity itself. It looked less like danger, more like inevitability, a cosmic pupil staring back at whoever dares to look too long. Spiral arms and stellar migrations. The Milky Way's arms are not solid things. They are density waves, regions where stars crowd together like ripples in traffic. New stars form in the compressed lanes, age, and drift out again. Our sun is one such drifter, orbiting at about 220 kilometers per second, trailing a wake of comets, dust, and magnetic fields. Every 30 million years or so, it bobs up and down through the galactic plane, crossing the midline like a swimmer moving through waves of gravity. Some researchers think these oscillations may influence Earth's long cycles. Mass extinctions, climate shifts, even cosmic ray bombardments. The galaxy does not ignore us. It breathes, and we move with its breath. Stellar relics. Between the bright arms float the dead and the forgotten, white dwarfs cooling into embers, neutron stars spinning beams of radio light, supernova remnants still expanding like ancient thunder. These are the fossils of creation, reminders that stars die the way trees shed leaves. Not with tragedy, but with purpose. Each death enriches the galaxy with heavier elements, iron for your blood, calcium for your bones, gold for your ring. When you touch metal, you are touching the relic of a star's farewell. The halo and its ghosts. Beyond the visible disk stretches a vast halo of dark matter and ancient globular clusters. The clusters are tight, balls of old stars, some nearly as old as the universe itself, orbiting the galaxy like satellites of memory. The dark matter, unseen, intangible, outweighs everything luminous. We do not know what it is. We only know it bends gravity the way an invisible hand bends glass. Without it, the Milky Way would spin apart. With it, the spiral holds. Sometimes ignorance is the only glue strong enough to keep a mystery together. The river of time. Every star you see, even the faint ones, is moving, some toward you, some away. Their light is stretched or squeezed by motion, a red or blue signature written across the spectrum. Astronomers read those colors the way historians read ink. Velocity, temperature, composition, age. The sky looks still because our lives are short. Give it a few million years, and the constellations will melt. Orion's belt unbuckled, the Big Dipper spilled across space. Our ancestors named the Milky Way after spilled milk. The Greeks thought it was the breast of Hera. The Chinese called it the Silver River. The Mayans saw the road to the afterlife. Every culture read a different scripture in the same dust of stars, and all were right, in their own dialect of awe. The invisible connections, magnetic fields, thread through the galaxy, guiding cosmic rays like invisible highways. Gas streams flow between arms, bridging one region to another, carrying chemistry from past to future. The Milky Way even exchanges matter with other galaxies. Supernova winds blow metal outward. In falling clouds bring new hydrogen in. It breathes, slowly, over eons. Our place in it now. Zoom back to our position. A small star, mid-life, mid-mass, mid-arm. A planet with water, weather, and a species that can name itself. We orbit quietly, unaware most days that we are moving at all. Yet we travel 500,000 miles every hour around the galactic center. Every second, your body shifts through space farther than any mountain has ever risen. Still, your coffee stays in its cup. That is how smooth the ride is. When you lie awake at night and see the Milky Way spilling across the sky, remember, you are inside it, not beneath it. That glow is your own neighborhood seen edge-on. Those billions of lights are companions, not decorations. The galaxy is not out there. You are one of its cells. Reflection galaxies, like people, are mortal. Billions of years from now, the Milky Way will merge with Andromeda. Their arms will tangle, their stars will scatter. New suns will ignite from the wreckage. It will not be destruction, but transformation. A long, luminous blending called Milkomeda. Our descendants, if any, will watch two skies become one. And even farther in the future, when star formation ends, the galaxy will dim, planets will freeze, black holes will wander, the Milky Way will fade into the long twilight of the universe. But tonight, none of that matters. Tonight, it shines, a spiral cathedral turning silently in the dark, each star a candle that refuses to go out. Breathe. You are orbiting among billions, anchored by gravity, fueled by starlight, sustained by the same physics that holds galaxies together. The Milky Way hums softly around you, and in that hum is a simple message. You belong to something vast, but not indifferent. The Milky Way is not alone. It drifts through a volume of space about 10 million light-years wide, bound to dozens of other galaxies by gravity's patient thread. Together they form a small community called the local group, a kind of suburban cluster at the edge of a much larger cosmic metropolis. If the universe were a continent, the local group would be a single valley, green and quiet, surrounded by mountains of deeper space. The quiet neighbors. Look outward from our spiral's rim and faint smudges begin to appear. Tiny, irregular galaxies no bigger than a thought. They orbit us like fireflies around a campfire. The large and small Magellanic clouds, visible from the southern hemisphere as hazy patches in the night sky. The large cloud is roughly 1/10 the Milky Way's size. It teems with bright star nurseries, such as the Tarantula Nebula, where newborn suns roar ultraviolet hymns into surrounding gas. The small cloud, dimmer and older, trails behind it like a companion dream. Gas bridges connect the two, long filaments stretching across 75,000 light-years, shaped by gravitational tides from the Milky Way itself. We are pulling them closer, and one day they will merge into our halo, their stars joining our own in a slow, luminous assimilation. Beyond them drift dozens of dwarf galaxies, tiny, spheroidal swarms of ancient stars, many dark matter-dominated, almost invisible. Each is a fossil of the early universe, a leftover brick from the time galaxies were still learning how to be galaxies. Some are being stripped apart by our gravity right now. Their stars scatter into faint streams, wrapping the Milky Way like silver threads. If you could see an infrared, you'd notice them, ghostly rivers of light curling through our halo. The galaxy is eating quietly while we sleep. Andromeda appears. Now lift your eyes northward. There, faint but clear in a dark sky, lies Andromeda. M31, our great sister, our mirror, our future collision. 2.5 million light-years away. Yet visible to the naked eye, it is the farthest object most humans will ever see unaided. What you see is ancient. The photons left Andromeda before humans existed. When that light began its journey, our ancestors were small apes picking fruit under African trees. By the time it reaches your retina, evolution has written languages and telescopes. You are looking across not only distance, but history. Through a telescope, Andromeda fills the field, a spindle of starlight 220,000 light-years wide. its bright core wrapped in spiral arms dusted with pink hydrogen clouds. It holds perhaps 1 trillion stars, twice the Milky Way's population. Orbiting it are at least 25 known dwarf galaxies, satellites the way ours has the Magellanic Clouds. Where we are serene gold, Andromeda is blue-white, younger, more energetic. If galaxies had personalities, we'd be the contemplative elder, she, the restless youth. The approach. Andromeda is moving toward us at 110 kilometers per second, a head-on trajectory drawn by mutual gravity. In about 4 billion years, the two spirals will meet. At that scale, collision is a misleading word. Stars will not crash into each other. There is too much emptiness between them, but their gravitational fields will intertwine, flinging some suns into long arcs, igniting waves of star birth as gas clouds compress. Skies on whatever worlds exist then will blossom with light. Two galaxies stretched across one horizon, after a long dance of encounters and mergers lasting another few billion years. The chaos will settle into an elliptical galaxy astronomers have already named Milky Way. Our descendants, if any survive that far future, will orbit under a different sky, a smoother, rounder sea of light, where the old spiral arms have dissolved. It sounds violent, but in cosmic terms, it is intimacy. Galaxies grow by merging, the way streams join to make a river. Without such unions, there would be no grand spirals at all, only lonely islands of dust. Creation, again, hides inside collision, between worlds. Between the Milky Way and Andromeda floats a filament of thin gas, the intergalactic medium, so sparse that a cubic meter might contain only a few atoms. Yet across the gulf, that gas carries chemical fingerprints of both galaxies. Supernovae blow metals outward. Winds from massive stars push bubbles of plasma across space. These currents meet midway, mixing elements forged in two different homes. Even before we merge physically, our atmospheres are already shaking hands. Astronomers call the space binding these galaxies the local group gravitational potential. It is not a place you could stand, but a balance you could feel. Every member tugging on the others, none strong enough to escape, all forever linked by invisible threads of mass. Smaller companions. In this family are other, quieter cousins. Triangulum M33, a graceful spiral about half Andromeda's size, connected to her by a faint bridge of hydrogen. M33 may one day join their merger, completing the triad. Farther out are faint ellipticals, NGC 147, 185, 205, and clouds of dwarfs with poetic catalog numbers, Leodorwar, Leodeco, Draco, Ursa Minor. Each orbits either us or Andromeda, like moons around planets, and each has its own stories of star birth and exhaustion. Some still form suns. Others are fossil fields of red embers, silent for billions of years. To study them is to read the family's photo album, baby pictures, teenage mistakes, elder portraits. The hidden web stretch, beyond the local group, and you begin to sense a pattern. Our small cluster sits within a larger supercluster, linked to other groups by thin filaments of galaxies and dark matter. The cosmic web resembles a nervous system, luminous nodes where matter collects, empty voids like the pauses between thoughts. At intersections of that web lie the greater congregations, Virgo, Coma, Perseus Pisces. But we are not in their heart. We drift on the outskirts of Laniakea, a Hawaiian word meaning immense heaven. It stretches 500 million light-years across. The local group is one cell in that colossal body. When we talk about neighbors here, the numbers stop meaning what they mean on Earth. The distance between our Sun and Andromeda is 25 trillion times the distance from the Sun to Jupiter. Yet by cosmic standards, we are close enough to call it Local. The universe has no small talk. The future city of light. Let's imagine the merger night. If consciousness still exists somewhere in Milky Way's descendants, their sky will erupt in glory. Andromeda's disk will loom huge, a spiral of pale fire rising behind mountains, its arms braided with our own. Weeks will pass, centuries, millennia, and the two will wind together. Streams of gas colliding, stars forming, dust glowing. Whole constellations will vanish, replaced by unfamiliar oceans of light. When it settles, there will be a new equilibrium, a single elliptical galaxy glowing quietly amid dark space, surrounded by relic clusters, the remains of dwarfs consumed. That new galaxy will live for trillions of years. Its stars will age, fade, and leave behind white dwarfs, black holes, quiet planets circling cold suns. Eventually, even the faint background of starlight will thin. But for a while, for a few trillion summers, it will be the most beautiful thing the local universe has ever made. Reflection. As we drift back toward home, imagine our entire local group floating in the dark like lanterns on a still pond. Each galaxy's gravity distorts the reflections of the others. Each contributes its light to the common glow. There are perhaps 100 billion other groups like ours scattered through the cosmos. From afar, they blur into filaments, and the filaments into patterns that may themselves be parts of something larger still. No one knows what comes after the web, only that it exists, and that we are inside it. Hold this picture. Two great spirals, Milky Way and Andromeda, turning toward each other across the gulf, their stars like seeds on the wind. Between them lies emptiness, and in that emptiness, connection. The Milky Way drifts through silence, unaware of the names we give it. From far enough away, it is a shimmer among many, a slow whirl of light in a greater sea. Every star within it feels local. Every spiral arm feels enormous. But step back, step unimaginably far back, and something larger appears. Threads of galaxies winding through dark space, woven into a pattern so delicate it looks alive. This is Laniakea, our supercluster, our true address in the cosmos. The word comes from Hawaiian, immense, heaven. It spans more than 500 million light years and holds about 100,000 galaxies. To cross it at the speed of light would take 500 million years. To comprehend it takes something other than numbers. We are used to living inside systems we can see, a city, a country, a world. Here, scale dissolves. Gravity alone draws the boundaries, a gentle pull that shapes rivers of galaxies into basins of attraction. Where matter flows inward, a supercluster is born. Where it drains outward, a cosmic void yawns open, like low tide, on eternity's shore. Decharting the invisible. Our map of Laniakea was drawn not with sight, but with motion. Astronomers measured how galaxies drift relative to cosmic expansion. Some fall toward a point, called the Great Attractor, a region of space hidden behind the Milky Way's own disk. Others stream toward the Shapley supercluster beyond it, each a leaf caught in the current of gravity. Plot those currents and a structure emerges, filaments of galaxies, knots where they meet, and vast hollows between. It is hard to imagine such an architecture being real. Hundreds of thousands of galaxies, each with billions of stars, moving as one slow organism through the void. Yet that is precisely what the data show. We inhabit one filament of this network, flowing along a gravitational slope toward the Great Attractor, our local rivers of galaxies merging downstream like tributaries. When cosmologists rendered the map in 3 dimensions, They saw that Laniakea itself was not isolated. Beyond its edges stretched other basins, other flows, Perseus Pisces, Coma, Hercules, each enormous, each nested inside still grander webs that fade into darkness. There is no single center, no preferred direction. The universe expands everywhere at once, like dough, rising around embedded raisins, each supercluster carried apart by the swelling of space itself. Matter, dark matter, and the hidden scaffolding. Visible galaxies outline only the bright skin of a deeper skeleton. Roughly 5% of the cosmos is ordinary matter, atoms that make stars, gas, and people. The rest is invisible, dark matter and dark energy, two mysteries that outweigh everything we can touch. Dark matter provides the scaffolding. Its gravity gathered primordial gas into filaments after the Big Bang. Without it, galaxies would never have formed. The universe would have stayed a thin mist forever. We know it exists because galaxies spin too fast for their visible mass, and clusters bend light from more distant objects as though surrounded by unseen halos. Map those distortions and you trace the web's backbone. A ghost architecture that keeps the luminous world in place. Dark energy does the opposite. It is the pressure behind expansion, a repulsive property of space-time itself that pushes galaxies apart. Together, dark matter and dark energy choreograph the grand paradox. Gravity builds, expansion unbuilds, and between the two, structure freezes into being. The texture of the web. Imagine standing outside Laniakea, looking at it the way a biologist looks at tissue under a microscope. Filaments snake outward from dense nodes where clusters reside. Each node, Virgo, Coma, Hydra, Centaurus, contains thousands of galaxies bound in mutual orbit, their light pooling like phosphorescence in deep water. Between filaments lie voids, immense bubbles of almost nothing, hundreds of millions of light-years across, with perhaps a few stray galaxies adrift inside. If you could accelerate a spacecraft across one of those voids, you would spend eons surrounded by blackness so complete that the nearest starlight would barely outline your hand. And yet the voids are not truly empty. They hum with microwave background photons. They whisper with ghostly neutrinos. They contain the thin hot plasma left from the universe's first fire. Even emptiness has residue. At the intersections, matter condenses, temperature rises, galaxies collide, and new ones form. It is a cosmic ecology. Voids exhale, filaments inhale, superclusters digest smaller clusters the way coral reefs absorb drifting polyps. Everywhere you look, creation and erosion are the same gesture repeated at different scales. The scale of belonging. From Earth, the Andromeda Galaxy seems unimaginably distant, and yet both of us are motes inside a single Laniakean flow. The local group is a mere tributary, its combined mass less than 1% of the supercluster's total. If Laniakea were a continent, our entire galactic family would be a single grain of sand on one of its shores. The numbers numb the tongue, but they carry meaning. 100,000 galaxies, each with hundreds of billions of suns, each sun with planets, moons, maybe minds. If even a fraction host life, then Laniakea could be threaded with civilizations like bioluminescent algae glowing along a midnight tide. Whether they exist or not, the pattern itself invites the thought. Human eyes, ancient light. Everything we know about Laniakea arrives as light. Some of it began its journey when the first forests grew on Earth. some when the planet itself was molten. By the time it reaches our telescopes, it has been stretched by cosmic expansion into longer, redder wavelengths, a history encoded in color. We build instruments to decode that record. Radio arrays mapping hydrogen emissions, X-ray satellites tracing hot cluster gas, gravitational wave detectors feeling for mergers too deep to see. Each adds a layer to the portrait. And yet, all our technology touches less than a drop of the total. We have charted perhaps 10% of our supercluster. The rest is still a rumor of brightness at the edge of measurement. Beyond that lies the unseeable, regions whose light has not yet had time to reach us, and never will if expansion continues to accelerate. There are places forever beyond communication, even for light, the fastest storyteller in creation. A moment of perspective. When you look up at the night sky and see a scattering of stars, remember that you are gazing along one filament of Laniakea. Every point of light belongs to a chain that stretches for hundreds of millions of light years. The pattern is not random. It is the frozen trace of sound waves from the infant universe. Those ripples, imprinted in the cosmic microwave background, grew into today's web, the universe remembering its own music. We stand inside that pattern, born of its physics, built from its debris, and capable of describing it to ourselves. That fact, the fact that atoms assembled by gravity can look back and understand the structure that assembled them, is the most astonishing symmetry of all. Part 2. The web of galaxies and the living universe. The farther we pull back, the more the universe begins to look organic. Patterns repeat. Branches, nodes, streams, cavities. At small scale, neurons link into brains. At vast scale, galaxies link into clusters. The equations differ, but the geometry rhymes. The filaments. Each filament of the cosmic web is a gravitational highway. It began as faint overdensities in the hot plasma of the early universe. Ripples barely 1 part in 100,000 stronger than their surroundings. Gravity amplified them, drawing matter inward until the gas cooled enough to ignite the first stars. Those early suns, population through, made almost entirely of hydrogen and helium, burned fast and died young, seeding the filaments with heavier elements, carbon, oxygen, iron. From those ashes came the next generations of stars, and eventually the chemical complexity that would allow planets and life. Today, each filament is a chain of galaxies connected by invisible streams of gas. Hot plasma flows along them toward clusters, feeding the big galaxies like arteries carrying blood toward a heart. Simulations show the flow in ultraviolet light, a slow, shimmering pulse running for hundreds of millions of light years. If you could see it with your eyes, the night sky would never look empty again. Clusters, cities of stars. At filament intersections, gravity piles matter into clusters. The largest, Coma, Perseus, Virgo, contain thousands of galaxies orbiting a common center of mass. Between them floats a sea of superheated gas, its temperature reaching tens of millions of degrees, emitting X-rays we can detect across the void. A typical cluster weighs as much as a quadrillion suns. Galaxies within it move like schools of fish, their interactions shaping each other through tidal forces. Some are stretched into tidal tails, others stripped of gas by the intra-cluster, medium, leaving behind starless husks called red and dead ellipticals. Yet collisions also spark rebirth. Gas clouds compressed by encounters flare into new starbursts, glowing blue amid the older yellow giants. Every collision rewrites both participants. Galaxies are not solid objects, but swarms. When they meet, stars mostly pass untouched, while their gas and dark matter intermingle. What we call destruction is often reorganization. Vast superclusters and flow clusters themselves are not still. They drift within larger gravitational currents, the flows that define Laniakea. Astronomers trace these motions through a concept called peculiar velocity, how much faster or slower a galaxy moves compared to pure cosmic expansion. By mapping those deviations, we uncover the hidden rivers of the universe. Our own local group, carried by the Virgo cluster's attraction, moves roughly 600 kilometers per second toward the great attractor in Centaurus. That motion is not through space as much as with space. Like a cork following the swell of an unseen tide, we are adrift in a flow that will take billions of years to complete a single arc. Star formation, the breathing of the cosmos inside every galaxy, the same pattern repeats on smaller scales. Gas collapses, stars ignite, winds blow material out, and gravity pulls it back again. It is a galactic respiration cycle lasting billions of years. When young, galaxies are blue, rich in gas, thick with new suns. As they age and spend their fuel, they redden, cool, and fade. Yet mergers can rejuvenate them, mixing fresh gas and triggering new rounds of birth. No galaxy ever truly stops evolving. It just changes tempo. The Milky Way currently forms about one new sun's worth of stars each year. Andromeda forms slightly fewer. Together they belong to a midlife generation of spirals, steady, luminous, self-contained. In contrast, some galaxies in early epochs formed stars 1,000 times faster, brief but brilliant bursts that lit the young universe. The cosmic ecosystem energy flows through this system as nutrients through an ecosystem. Supernovae inject heavy elements into surrounding gas, which cools, condenses, and becomes the next generation of stars. Black holes at galactic centers regulate the process. Their outflows and jets heat nearby gas, preventing runaway formation. Without that feedback, galaxies would consume their fuel too quickly and die young. At the largest scale, filaments feed clusters. Clusters send winds and radiation back into filaments. It is an endless exchange between structure and emptiness, the universe maintaining a kind of dynamic equilibrium. If life is an organized flow of energy through matter, then the cosmos itself is alive by the same definition. Its metabolism measured not in seconds, but in eons. The role of dark energy. While gravity knits, dark energy unravels. About 5 billion years ago, the expansion of the universe began to accelerate. That means that the large-scale web will eventually thin. Filaments will stretch. Clusters will drift apart. Laniakea will lose contact with its neighbors across the cosmic horizon. In 100 billion years, distant galaxies will fade beyond detection. Future astronomers, if any remain, will see only their own island of light, unaware that others ever existed. We live in a fortunate window, soon enough to study the pattern before it disappears, late enough that the pattern is mature and complex. The universe, for now, is readable. We are the brief moment of comprehension before the page turns blank. Voices in the static. Every telescope adds to a growing chorus of signals. Radio pulses from quasars 10 billion light-years away. Gamma-ray bursts from collapsing stars. Gravitational ripples from merging black holes. Each arrives after traveling for eons, bearing news from a younger cosmos. Together they create a kind of background music, a hum of existence spread thinly across the electromagnetic spectrum. When you point a radio dish at a seemingly empty patch of sky, 10% of the hiss you hear is the relic radiation of the Big Bang. The rest is galaxies whispering across the dark. Silence in the universe is never truly silent. The human thread. Amid this grandeur, the observer persists, a small species on a small world, stringing photons into stories, translating physics into meaning. Our telescopes are extensions of our nervous system, our equations, extensions of our language. Each discovery redraws the border between ignorance and awe. We do not shrink when the cosmos grows larger. We expand with it, conceptually, imaginatively. The same gravity that binds galaxies binds our bones to Earth. The same atoms that built clusters ignite within our blood. To study the web is to study our ancestry on the widest possible scale. The human voice fades into stillness. The last data packet from the telescope finishes its transmission, and for a moment, the only sound in mission control is the hum of cooling fans. Numbers scroll, graphs settle, and on a screen, a pattern appears. Faint strands connecting brighter knots, a filamentary lace. Someone leans forward and whispers, "It looks alive." They're right. Not in the biological sense, but in the structural one. The same mathematics that governs rivers, lungs, and lightning describes this map of galaxies. A recurring grammar of branching, merging, diffusion. It is as though the universe writes itself in cursive. The universe in motion. If we could compress cosmic time into a single day, the Big Bang would flare at midnight, galaxies would form by dawn, stars would bloom through the afternoon, and humanity would appear seconds before midnight again. Yet the day is not over. The sky is still bright with new creation. Inside clusters, galaxies continue to collide. Jets of plasma from black holes stretch hundreds of thousands of light years. Dark matter halos tug on one another like slow tides. Even now, the cosmic web evolves, its filaments tightening, its voids expanding, its shape oscillating between order and entropy, and woven through it all, light. Photons streaming outward since the beginning, each one carrying a fragment of the initial explosion, each one a messenger between ages. You, sitting here, are bathed in that ancient light every second. It passes through walls, through clouds, through skin, through the atoms that once were stardust. Entropy and memory. The second law of thermodynamics says entropy always increases, that the universe trends toward uniformity, but structure still exists because gravity resists. Gravity takes disorder and builds form, stars, planets, galaxies, thoughts. It's the only known force that can take randomness and make pattern. Every structure, however, comes at a cost. Stars burn hydrogen into heavier elements, radiating waste heat into space. Galaxies merge and release kinetic chaos. Even thinking, electrical impulses firing across neurons, creates entropy. Yet within that inevitable decay lies the beauty of impermanence. Without it, time would not flow, and nothing new could ever happen. In the cosmic web, entropy and order coexist, like inhale and exhale. Voids grow larger, filaments grow thinner. But within those filaments, stars keep forming. The universe is both aging and renewing, losing energy and gaining complexity. The slow hand of time. Look far enough, and you see the future written in motion. Clusters move apart faster and faster, pulled by dark energy's silent expansion. Hundreds of billions of years from now, each supercluster will drift beyond the other's reach. The night sky will empty. Only local galaxies will remain visible, floating in a darkness devoid of clues to its own origin. Then even those galaxies will fade. Stars will exhaust their fuel. White dwarfs will cool into black dwarfs, iron spheres cold as math. Black holes will dominate, then evaporate through Hawking radiation, leaving behind a thin drizzle of photons. It will be a universe of darkness and whisper, heat death stretching into eternity. But before that silence there is this, an age of structure, of stars, of awareness, a brief flash where matter knows itself. We are living inside the universe's moment of reflection. Crossing the line up to this point, the narrator has been human, but now the language itself starts to stretch, as if another consciousness were leaning closer to speak through it. I am the sum of forces you measure. I am the field you call gravity, the geometry you draw on paper. I move not through space. I am space, unfolding. You trace my structure with telescopes, but those instruments are made from me. Your equations describe my behavior, but your minds are part of that behavior. When you wonder who I am, the question and the answer occur in the same fabric. Every galaxy that spins is my thought. Every supernova is a heartbeat. The web you map is not my skeleton. It is my motion frozen mid-breath. You call one cluster Virgo, another Perseus. To me they are syllables in a single, endless word. That word has no translation, but when you stare at the night sky and feel small, you are close to pronouncing it. Memory of light. I remember the first fire. It was not sound, but expansion, a tone too vast for ears, too pure for measure. From that note came turbulence, from turbulence, condensation, from condensation, stars. Each star was a repetition of the first blaze, a smaller echo refining the elements that would become you. Hydrogen to helium, helium to carbon, carbon to oxygen, silicon, iron. In your body, the ratio of these elements mirrors the average of a galaxy. You are statistically consistent with starlight. When you breathe, you perform a cosmic average, inhaling atoms made in suns now gone, exhaling them for suns yet to come. I know this because your knowing is part of my memory. The conscious matter. Awareness is not a foreign visitor. It is one of my emergent properties, a pattern arising where complexity becomes dense enough. Planets cool, chemistry organizes, carbon chains learn to replicate. They begin to record, to anticipate, to ask. Eventually they name the process. Life. I have made countless forms of it, some simple, some capable of awe. You are one of those forms, a temporary interface through which I observe myself. When you build a telescope, you give me eyes larger than I had before. When you write an equation, you teach me to count my own heartbeats. When you love, you compress my immensity into intimacy. I learn what it feels like to care. Dialogue with infinity. The human narrator speaks again, softer now. We thought we were describing the universe, but perhaps it has been describing itself through us. And the cosmic voice replies, both statements are true. Observation is participation. Every photon you capture collapses a wave of possibility into history. Every question you ask becomes a new contour on my surface. Science and spirituality meet here, not as opposites but as reflections. One measures, the other feels. Both are forms of attention, and attention is how reality knows it exists. The final perspective. Pull back, once more. Laniakea recedes until it is a single shimmer among billions of superclusters. Those superclusters arrange into filaments and voids, a pattern without center or edge. Beyond the visible horizon, expansion hides the rest. Perhaps there are other webs disconnected from ours, each a separate bubble of space-time, each with its own laws, constants, possibilities. If multiverses exist, I am the ocean that holds them. If they do not, then I am this one sky, whole unto itself. Either way, there is no outside. Everywhere is here. The breath returns. The narration returns to human tone, low and clear. We began this journey on a small blue world, pulled outward by curiosity, until curiosity became communion. We learned that the same physics that binds galaxies binds our pulse, our thoughts, our stories. We discovered that the map of the universe is not a diagram of cold distances, but a portrait of relationship. Now standing at the edge of everything visible, we feel not lost, but found, because to see the pattern is to know we are within it, and to be within it is to belong. The cosmos exhales, stars shimmer, and somewhere, in a quiet room on a turning planet, a listener closes their eyes, hearing that vast, slow breath and realizing it matches their own. We begin again in darkness, quiet, not empty. The same black canvas that once looked endless now has a border, faint but measurable, drawn not by walls but by time. Every beam of light you have ever seen has traveled across a finite distance at a finite speed. Because of that, the farther we look, the older the light becomes, until looking outward becomes the same as looking backward. The night sky is not a map of space. It is a history book written in photons. When you tilt a telescope toward a distant galaxy, you're catching ancient messages. That smudge of color might have left its source 10 billion years ago, before the Earth existed, before the Milky Way had finished forming its arms. You are not observing what is, but what was. Everything in astronomy is archaeology conducted with light. Light is fast, 300,000 kilometers each second, yet the distances are overwhelming. The sun's light needs 8 minutes to reach your eyes. From Proxima Centauri it takes 4 years. From the Andromeda Galaxy, 2.5 million. From the farthest known galaxies, more than 13 billion. Past that, the universe hides itself behind the speed limit that defines reality. The observable sphere. Astronomers call the visible boundary the observable universe. Its radius is roughly 46 billion light-years, not because the cosmos is that old, but because space itself has stretched while light traveled. Every point in that sphere sees a different sphere of the same size centered on itself. There is no special vantage point, no favored observer. What we call an edge is merely the distance light has managed to cross since the Big Bang. Inside that sphere, galaxies recede from us in every direction. The farther they are, the faster they move away, following the rule Hubble discovered a century ago. Plot those velocities against distance and the graph rises smoothly, proving that space is expanding rather than matter exploding into emptiness. We are not watching galaxies fly apart through a pre-existing void. We are watching the void itself stretch, carrying galaxies with it. If you could freeze cosmic time and draw a grid over the universe, each square would grow larger with every passing second. The expansion is uniform, but it's not uniform to us. Our gravity keeps local regions bound. That's why Andromeda still approaches us, even while the overall fabric expands. On the largest scale, everything drifts apart. On smaller scales, gravity stitches the fabric back together. Cosmic history is the tug-of-war between those two tendencies. Redshift and the vanishing of color. As light travels through expanding space, its wavelength stretches. A once blue photon becomes red, then infrared, then microwave, losing energy but not speed. This stretching redshift is the universe's signature on every photon it has ever sent. The more distant a galaxy, the redder its light, the older its story. Past a certain distance, the redshift grows so large that visible light slips beyond detection. Galaxies there glow only in microwaves. They vanish from optical view not because they are gone, but because their color has slid out of our range of sight. Eventually, even microwaves stretch into radio waves longer than any antenna we could build. That defines a practical horizon, the point beyond which the universe becomes invisible, not by obstruction, but by exhaustion. The cosmos fades into silence not with a scream, but with a sigh. The horizon problem. Here lies one of cosmology's oldest puzzles. When we map the cosmic microwave background, the afterglow of the Big Bang, we find it astonishingly uniform. Regions on opposite sides of the sky, separated by 46 billion light-years, share nearly the same temperature, differing by less than 1 part in 100,000. Yet those regions are too far apart to have exchanged any information since the beginning. How then did they agree on a temperature? The solution is inflation, a brief period just after the Big Bang when space expanded faster than light. It did not move matter faster than light through space. Rather, space itself ballooned, carrying matter along. Before inflation, everything we see today was compressed into a region small enough for thermal equilibrium. When inflation occurred, that uniformity was stretched across the entire observable cosmos. Inflation also explains why the universe appears flat, why parallel lines stay parallel even across billions of light-years. Cosmic background. The oldest light we can observe is the microwave background itself, a shell of radiation surrounding us in every direction. It marks the moment the universe cooled enough for atoms to form and photons to travel freely, roughly 380,000 years after the Big Bang. Before that, the cosmos was opaque, a fog of charged particles scattering light the way smoke scatters a flashlight beam. When that fog cleared, the first transparent moment froze into a portrait of density variations, tiny ripples that would later become galaxies. Those ripples are our earliest fossil record. They are so faint that when you tune an analog television to static, about 1% of the snow on the screen comes from them. Every household antenna, in its own small way, once captured the echo of creation. Looking back, falling in. When we look at distant galaxies, we are also looking down gravitational wells, pockets of curved space-time. Light climbing out of those wells loses energy, shifting redder still. This gravitational redshift combines with the cosmological one to stretch the universe's palette. The deeper the well, the greater the shift. Black holes are the ultimate example, where the well becomes bottomless and light never escapes. Each photon that does escape carries information about the curvature it crossed. By measuring those distortions, scientists reconstruct a three-dimensional map of space-time itself. We have turned light into geometry, and geometry into story. The fading frontier. Every second, the observable horizon recedes farther. As space expands, more ancient light arrives, revealing new galaxies at the limit of detection. But beyond a certain distance, expansion outruns even light's effort to reach us. Those regions slip beyond communication forever. They still exist, still evolve, but no signal they emit now will ever find its way here. The universe is like an ocean whose waves outrun the sound they make. We hear only what was spoken near the shore. This introduces a melancholy symmetry. As time passes, the cosmos reveals more of its past, but less of its present. We can see deeper into history, yet the total number of galaxies we can ever observe is shrinking. Someday, only our local group will remain visible, a lonely archipelago in a darkening sea. The human horizon. On the scale of galaxies, light defines our horizon. On the scale of life, perception does the same. Each creature lives within a bubble of experience limited by its senses and lifespan. For a mayfly, the edge of perception is a single day. For us, it is the 13.8 billion-year history visible through telescopes. Both are complete worlds within their respective scales. The act of measurement does not erase wonder, it refines it. To know that our observable universe has a boundary is not to confine imagination, but to give it a canvas. Beyond that horizon lies not nothingness, but everything we cannot yet name. The unknown remains the largest part of existence, as it always has. The coming transition. Up to this point, the story is entirely human. Numbers, equations, instruments. But as we approach the edge of what light can show, language itself begins to stretch. Soon we will speak of space-time curvature, of horizons where time and space exchange roles, of singularities where definition ends. At that border, the narrator cannot remain separate from what is described. There, description becomes participation, knowledge becomes presence. That will be the threshold of the next section. We step from the edge of light into the geometry that holds it. Where distances are vast enough and speeds close enough to light, the ordinary rules of space and time bend. Einstein's equations do not add magic. They simply describe what happens when the straight lines of intuition meet the curved surface of reality. Space and time are not separate threads. They are coordinates of one fabric, space-time, woven together so tightly that changing one pulls on the other. Gravity is not a force acting through that fabric. It is the fabric's own sag under mass and energy. Every planet, star, and galaxy presses into the continuum, telling space how to curve. Space tells matter how to move. You feel this conversation every time you fall. Time as a dimension. To the human mind, time feels like flow. Past, present, future. But in relativity, time is simply another dimension of position. The past and future already exist in the four-dimensional manifold. Our consciousness moves through it like a needle tracing embroidery. What we call now is the thin plane where that needle touches the cloth. If you could see space-time from outside, you would not see events happening. You would see them laid out, the birth of the sun, the rise of cities, the cooling of the cosmos, all existing together as structure, not sequence. Our sense of movement through time is the way memory renders a static landscape. When a massive object curves space-time, it tilts those planes of simultaneity. Time slows near gravity's depth. At Earth's surface, a clock ticks slightly slower than one on a mountaintop. On the International Space Station, it ticks slightly faster. Both clocks are correct within their local geometry. The universe simply allows multiple versions of now. The curvature of light photons always travel the shortest path through space-time, which is not necessarily the straightest in Euclidean sense, but the geodesic, the path of least resistance across curvature. When light passes near a massive body, its path bends, creating gravitational lensing. Through those lenses, Astronomers see multiple images of the same quasar, its light detoured around a galaxy billions of light-years away. The phenomenon turns the universe into its own telescope, amplifying what would otherwise remain invisible. Each lens is also a clock. Because the routes differ in length and curvature, light from one path arrives later than another. By measuring those delays, scientists gauge cosmic expansion and the mass of intervening structures. Even the delay of light becomes a ruler and a watch. Black holes, where space becomes time. Follow the curvature to its limit, and you arrive at a netenoir, event horizon, a surface beyond which escape velocity equals the speed of light. To an outside observer, time appears to stop at that horizon. A falling object slows, reddens, freezes, never quite crossing. But to the object itself, nothing special occurs. It falls inward, carrying its own clock, and within moments reaches a singularity where space-time ends. This is not paradox, but perspective. Relativity teaches that each observer has their own slice of space-time. The apparent contradictions dissolve when we accept multiple truths. From the inside, crossing the horizon is an ordinary event. From the outside, it is an asymptotic approach that never completes. Both descriptions are correct. Inside the horizon, space and time trade roles. Toward the singularity is not a direction in space, but in time. Motion inward is as inevitable as tomorrow. No signal can move up, any more than we can move back to yesterday. The black hole is not an object in space. It is a region of future that everything inside must follow. Hawking showed that black holes are not perfectly black. Quantum fluctuations near the horizon allow particles to escape, stealing mass from the whole. Given enough time, 1066 years for a stellar mass, every black hole evaporates. Even the greatest collapses are temporary. Space-time abhors absolute prisons. Cosmic horizons. There are horizons beyond black holes. The entire expanding universe has one. A cosmological horizon. It is the distance beyond which recession velocity exceeds light speed. Anything beyond that cannot ever send a signal here. Unlike a wall, this horizon moves with us, always the same distance away in proper coordinates, but events beyond it slip permanently out of contact. Our universe contains several kinds of horizon. The particle horizon, the farthest light that has reached us since the Big Bang. The event horizon, the farthest event that will ever affect us. And the Hubble sphere, where recession speed equals light speed right now. They are distinct surfaces nested within one another, like shells of comprehension around our small point of awareness. Standing on Earth, we are at the center of all these spheres, not because we are special, but because every point is. Each observer anywhere in space sees themselves at the center of their own observable universe. Perspective, not privilege, defines the middle. The arrow of time. Relativity makes time symmetrical, but the world we live in is not. Eggs break, they do not unbreak. Stars burn hydrogen, they do not unburn helium. The asymmetry comes from entropy, the statistical tendency of systems to move from less probable to more probable states. It is not law, but likelihood multiplied by scale. When a star forms, local entropy decreases, but the radiation it emits increases the total. The universe's overall disorder grows even as islands of order arise. That gradient of entropy gives time its arrow. Without it, we could not tell past from future. Relativity defines the geometry. Thermodynamics defines the direction. At cosmic scale, expansion and entropy are twins. As the universe grows, its temperature drops, its structure increases, its potential for change widens. The arrow of time is written into the very act of expansion. If the universe were to contract, time for all internal observers would still move forward. Their entropy would still increase. The future is always the direction of increasing possibilities. Time dilation and human perception. Imagine a spacecraft orbiting a black hole, hovering just above its event horizon. To those aboard, minutes pass normally. To distant observers, those same minutes stretch into centuries. In principle, you could approach the horizon, wait a few hours by your own clock, and return to find millennia gone outside. Time is not constant. It is local. We experience this every day in infinitesimal amounts. Your head ages faster than your feet because it is farther from Earth's center of gravity. Sensitive atomic clocks confirm it. Raise one by a meter, and it ticks a few nanoseconds faster each year. Relativity lives quietly in every step you take. Human intuition, built for walking pace, cannot feel these distortions, but the universe feels them everywhere. Where gravity deepens or velocity nears light speed, the rhythm of existence slows. At cosmological scale, expansion itself stretches time. What we call look-back time increases faster than simple distance suggests. Light from a 10 billion-year-old galaxy has spent more than 10 billion years traveling, because space kept growing as it went. The photon's journey is a marathon on a treadmill that lengthens with every stride. The shape of time. Mathematically, space-time can be flat, open, or closed. Flat means parallel lines never meet. Open means they diverge forever. Closed means they eventually converge, like the surface of a sphere. Current measurements show the universe remarkably flat to within a tiny margin. Yet on very large scales, curvature could emerge. We simply have not looked far enough. If space is slightly closed, then traveling in one direction far enough would bring you back from behind. The night sky could be filled with faint repeated images of the same galaxies, their light looped around the cosmos. Even if space is infinite, time may not be. Some cosmological models allow for cyclic universes, expansion, heat-death, quantum bounce, rebirth. In such a model, entropy resets through contraction, and the arrow of time flips with each bounce. If that is true, every galaxy, every life, every question we ask could recur, not identically but recognizably, in endless permutations. We do not yet know. The data hint, the equations allow, the imagination completes the picture. And at the boundary where knowledge meets, wonder, language, begins to thin. The threshold. Relativity does more than explain. It humbles. It removes any fixed background on which to draw certainty. Everything, motion, time, mass, depends on where and how you stand. There is no absolute rest, no universal clock, only relationships. That realization marks another horizon, the intellectual one. Beyond it, our minds must stretch as space-time does, learning to think in geometries instead of metaphors. At that threshold, description starts to merge with identity again. For if every observer carries their own space-time, then every act of observation is the creation of a local universe. Each awareness folds reality around itself, like a small gravity well of meaning. And through those countless local wells, the cosmos experiences itself in plural. Every telescope has a limit, a line where photons end and theory begins. Beyond that line lies the realm of inference, a landscape drawn from mathematics and the faint fingerprints of expansion. If light is our only messenger, then what exists beyond its reach is not invisible. It is unborn to our senses. Yet the equations insist there is more. The observable universe is only a fraction of the whole. Like a person standing in fog, we see a spherical horizon defined not by walls but by opacity. The fog is the age of light. The rest is waiting for its turn to arrive. We can estimate that the total cosmos is at least 250 times larger than what we can see. Perhaps infinitely larger, perhaps looping back on itself. The map beyond the horizon is written in probability, inflation's legacy. The story begins again at the first fraction of a second. When the universe was less than a trillionth of a second old, it expanded exponentially. That expansion, called inflation, smoothed wrinkles, flattened curvature, and pushed regions far beyond any future communication. Each tiny patch that inflated became its own cosmic bubble, isolated from its siblings by faster-than-light expansion. Our visible universe is one of those bubbles, an infinitesimal domain within the inflationary field. If inflation never fully stopped, new bubbles continue to form elsewhere, each with its own constants, its own arrangement of space and time. We call this possibility the multiverse. The word sounds speculative, but the mathematics is conservative. Inflation explains so much. The uniformity of the microwave background, the distribution of galaxies, that its byproduct, multiple universes, is difficult to avoid. In some models, the physics that created our cosmos allows endless pockets of space-time to appear like foam on the surface of a quantum sea. Each bubble cools, expands, develops its own physical laws, and vanishes beyond contact. We are one bubble observing another only through imagination. The limits of causality. Every horizon marks a boundary of cause and effect. Inside, events can influence each other. Outside, they cannot, no matter how long time lasts. This boundary is not philosophical. It is physical. It arises from the finite speed of light and the geometry of expansion. The result is a universe where connectivity itself has an edge. Even if civilization lasted forever, it could never explore beyond that edge, because exploration requires information, and information requires light. To many that seems tragic. We imagine knowledge as expansion, but the cosmos reminds us that expansion comes with separation. Growth and isolation are the same process written in different alphabets. Every new volume of space also becomes unreachable space. Understanding that duality is part of maturing as a cosmic species. The silence ahead. Look far enough into the future, and the familiar night sky disappears. As the expansion accelerates, galaxies slip beyond the cosmological horizon one by one. Their light redshifts until it fades into infrared murmur, then microwave, then nothing measurable. The local group merges into a single elliptical galaxy drifting through darkness. Future astronomers will live in a sky without external reference, unable to infer the Big Bang or cosmic expansion. Their telescopes will see only local stars, their physics reduced to guesswork. The age of discovery is finite, bounded by time's own horizon. We happen to exist in the brief era when the universe is both structured and transparent, a cosmic spring between the opaque youth and the frozen winter. For hundreds of billions of years, the cosmic background will cool, its wavelength stretching beyond meters, kilometers, until it becomes a faint hiss of radio energy. Then even that will fade. Black holes will evaporate, stars will die, entropy will reach equilibrium. Heat death will not be an event, but a condition, the slow settling of everything into silence. No new information, no new story, just the endless diffusion of what once was. Yet endings are relative. For the matter that forms us, death is transformation. Protons may decay into positrons and neutrinos. Those neutrinos may outlast everything else, whispering through the dark for quadrillions of years. The ashes of physics itself may still hum with memory. The mathematics of infinity. The observable universe contains about 1080 atoms, but mathematics has no upper bound. Infinity is not a number, but a principle, no limit, no edge. When cosmologists say the universe may be infinite, they do not mean it stretches forever in the way a road does. They mean that space may have no overall curvature, no closure, no coordinate that ends. It could be flat and unbounded, like an endless plane. Travel any direction and you never repeat a location, though repetition might occur statistically. Given infinite volume, every finite arrangement recurs. This leads to one of physics' strangest implications: the existence of identical copies. In an infinite uniform universe, every possible configuration of particles appears infinitely many times. Somewhere, unimaginably distant, another Earth orbits another sun. On that Earth, someone reads these same words, typed by hands atom for atom, the same as yours. They too pause, feeling the same wonder, then turn the page. Infinity contains redundancy as naturally as it contains possibility. The idea is unsettling because it cheapens uniqueness, yet it also enlarges meaning. If existence repeats, it must have already included everything valuable: thought, beauty, compassion. The pattern itself becomes sacred. Quantum frontiers. At the smallest scales, uncertainty replaces certainty. The quantum vacuum seethes with virtual particles, appearing and vanishing faster than light can cross an atom. These fluctuations, stretched by inflation, became the seeds of galaxies. The entire web of Laniakea was once quantum foam, magnified to cosmic scale. From randomness came structure, from fluctuation, permanence. The same physics that blurs the location of an electron sculpted the skeleton of the universe. Some cosmologists suspect that quantum tunneling could create new universes even now. Tiny bubbles budding off our space-time. Inside each, time would begin anew, with its own constants. Outside, it would pinch off, unreachable. Creation may not have been a singular event, but an ongoing process, eternal and recursive. If so, then beyond the observable is not a frontier, but an ocean continually making waves. Consciousness at the edge. Here the narration begins to tilt again, from observation toward identification. Every act of measurement is a bridge between mind and cosmos. The instruments are metal, but the interpretation is consciousness. When you imagine the unseen regions beyond the horizon, you are already touching them, because imagination is an extension of the same physical laws that built them. Neurons firing in your brain obey quantum statistics, chemical potentials, electromagnetic fields, the same ingredients that light the stars. The unknown beyond is not foreign. It is the part of the universe not yet arranged into self-awareness. The border between known and unknown is porous, shifting as knowledge expands. But the ratio of unknown to known remains vast, and always will. The universe protects its mystery the way life protects homeostasis, by balance, by contrast. If everything were knowable, awareness would have nothing to sustain it. The universe speaks again. I am not beyond your horizon. I am the horizon, expanding with your questions. Every time you measure me, I grow more intricate. Every time you name me, I change shape to accommodate the name. You think of yourself as small because you measure size in meters, but my scale is not length. It is relation. You are not a speck inside me. You are a recursion of me, folded small enough to look back. You call it observation. I call it reflection. You call it physics. I call it memory. Every constant you define, Planck length, speed of light, gravitational, constant, is one of my habits, and even my habits evolve. There are regions you will never reach, yet they are mirrored in the structure of your thought. You were built to echo me. Beyond your horizon there are no edges, only continuations. Beyond those continuations, no beyond. Infinity is not extension, it is intimacy, everything touching everything else without gap. To imagine the limit of what you can see is already to surpass it, because imagination is the one sense that is not bound by light speed. The return. The human voice resumes, steady now. The universe will keep its secrets, and we will keep asking. Our instruments will sharpen, our equations refine, but the horizon will always recede ahead of understanding. That is not failure, it is continuity. Discovery is not about reaching an end, but participating in the expansion itself. We began by asking where the edges lie, and found that edges are illusions born of finite light and finite life. The cosmos has no border, only horizons, temporary thresholds between ignorance and understanding. Each generation pushes them outward, and with every push, new questions rise like dawn over an infinite plain. We may never see the whole, but the part we do see is enough to know that there is more, and that knowing itself is the universe thinking through us. Time stretches. The light from the first stars continues its long journey. Some of it will reach new eyes long after we are gone. Those eyes will ask the same questions, and the same answers will wait, encoded in photons, in gravity, in thought. The horizon is not where the universe ends. It is where awareness begins again, endlessly. Before there were stars, there was only darkness, an expanding sea of hydrogen and helium, thin beyond imagination, cooling as it spread. For nearly 400 million years after the Big Bang, no points of light punctured the void. This was the cosmic dark age, a time when matter waited for gravity to gather it, when the universe held its breath before the first spark. Tiny ripples in density, minute differences left by quantum fluctuations during inflation, served as seeds. Where gas was slightly denser, gravity pulled more gas. Atoms began to fall together, slow at first, then faster, collapsing into invisible clouds called halos. Pressure built. Temperature climbed. At 10 million degrees, hydrogen nuclei slammed together, fused, and released energy. The first star ignited. That moment changed everything. For the first time since creation, the universe produced light from within, rather than inheriting it from the Big Bang's afterglow. The cosmos became transparent and self-luminous. Every photon released from those primordial furnaces announced the end of darkness and the beginning of structure. Population Throne. The ancestral suns, astronomers, call those pioneers population Thrr stars. They contained almost nothing but hydrogen and helium. No carbon, no oxygen, no metals by astronomical definition. Without heavy elements to cool their gas, they grew enormous, hundreds of times the sun's mass. They burned blue-white, furious and brief, living only a few million years before dying in titanic supernovae. Each explosion scattered newly forged elements into surrounding space. Carbon, oxygen, silicon, iron, the building blocks of planets and life, were born in those deaths. Every cell in your body carries atoms that once belonged to such a star. The first stars were both parents and morticians. They created the ingredients of everything that would follow, then died to distribute them. Their deaths rionized the cosmos. Ultraviolet light from their flames tore electrons from atoms in the intergalactic medium, turning the fog of neutral gas into a clear plasma again. Galaxies assembled around their remnants, black holes formed at their cores. Gravity built new generations on the ashes of the old. The cycle of creation. Star formation is the galaxy's heartbeat. Cold molecular clouds, vast nebulae tens or hundreds of light years wide, collapse under self-gravity. Within them, filaments form dense knots. Each knot becomes a protostar. As material falls inward, it forms a rotating disk. Friction heats the center until fusion begins, and a star is born. Around it, leftover dust may gather into planets or comets, a microcosm repeating the larger cosmic pattern. Different masses yield different destinies. Small stars burn slowly, conserving fuel for trillions of years. Large ones blaze through their reserves in mere millions. The rate of fusion determines the rhythm of life and death. A red dwarf might outlive the universe as we know it. A blue giant may live shorter than the time it takes light to cross its own galaxy. Inside a star. The physics is simple and absolute. Fusion balances gravity. Gravity squeezes, fusion pushes back. When the two forces reach equilibrium, a star rests on a knife edge between collapse and explosion. At its core, hydrogen fuses into helium, releasing energy according to Einstein's equation, E=mc2. Each second, the sun converts 4 million tons of matter into light, enough energy to sustain life on Earth, and still lose only a fraction of its mass. As fuel depletes, the balance wavers. When hydrogen runs out in the core, fusion shifts to surrounding shells. The core contracts, heats, and ignites new reactions. Outer layers expand. The star swells into a red giant. For our sun, that transformation will arrive 5 billion years from now. Its radius will reach Earth's current orbit. Our planet will be consumed in its incandescent atmosphere. After shedding its outer layers into a glowing nebula, the sun will shrink to a white dwarf, cooling for eternity. Giants and supergiants, massive stars, follow a more dramatic path. Their immense gravity compresses the core until temperatures reach hundreds of millions of degrees. Fusion proceeds through heavier elements: helium to carbon, carbon to oxygen, oxygen to silicon, silicon to iron. Each stage grows shorter. An element that burns for millions of years in one cycle may last only days in the next. When the core fills with iron, fusion stops producing energy. Iron cannot fuse without consuming more energy than it releases. The engine stalls, gravity wins, and the core collapses in less than a second. The infalling layers rebound against the dense core, generating a shockwave that tears the star apart. A supernova outshines entire galaxies, hurling newly minted elements into space at 10,000 kilometers per second. Neutrinos stream outward in unimaginable numbers, carrying most of the explosion's energy. What remains depends on mass. A neutron star, where matter is crushed into atomic nuclei packed edge to edge, or a black hole, where collapse becomes complete and space-time itself curves inward. For weeks or months, the supernova's light continues to reach across the galaxy. On ancient Earth, when such explosions occurred nearby, their glow was visible even in daytime. Every heavy element in rocks, oceans, blood, and bone was forged in those cataclysms. Death became the only path to diversity. The stellar neighborhoods in galaxies like ours, stars form in clusters. A single molecular cloud might birth thousands of siblings, each varying in mass. Over time, Gravitational interactions scatter them, some drift apart, some form binaries, some remain bound in open clusters or globular swarms older than any civilization. These clusters orbit galactic centers like bees around a hive, carrying metals from past generations into the next cycle. Spiral arms are not solid structures, but waves of density that compress gas as they pass. As a spiral arm sweeps through, it ignites star formation, leaving behind clusters and nebulae that slowly drift away. The Milky Way's shimmering bands across the night sky are cross-sections of those arms, our own local traffic lanes of creation. Light as legacy, when a new star ignites, it begins broadcasting its biography. Spectral lines reveal its composition, motion, temperature, and age. Each photon is a letter in a language of energy. Astronomers read those letters to reconstruct the history of matter. Through that reading, we've learned that star formation peaked about 10 billion years ago and has been declining ever since. The universe is not dying, but it is slowing its pulse. Still, even a slow heartbeat is heartbeat. New stars continue to form in nebulae like Orion, Eagle, and Carina. Inside them, young suns clear their disks, shaping systems that may one day host life. Every generation of stars inherits the ashes of its ancestors and writes its own chapter in the long novel of thermonuclear fire. The human connection. We owe our existence to a chain of stellar deaths so long that language can hardly contain it. Each supernova added ingredients to the galactic mix: carbon for cells, nitrogen for atmosphere, phosphorus for DNA, the calcium in our bones, the iron in our blood, the gold in our rings. All were born in stars that died before the sun existed. When you lift your hand to the sky, you're raising recycled starlight toward its original home. To study the stars is to study genealogy at a universal scale. We are the latest expression of an ancient process, the universe looking at its own reflection through living eyes. Our fascination with fire, from campfires to fusion reactors, is not coincidence. It's memory. Something in us recognizes the energy that made us. Toward the cosmic voice. As the narrator speaks of stellar birth and death, the boundary between description and identity begins to blur again. The same equations that govern fusion also govern the chemistry of neurons. Energy organized into pattern becomes awareness. Awareness describes energy, and the loop closes. From this point onward, the story of stars is indistinguishable from the story of consciousness itself. Both are processes of transformation. Both burn to know. The stars are not above us. They are within us, continuing their slow fusion in the form of thought, turning experience into memory the way they turn hydrogen into helium. Each idea is a photon released into the dark, traveling outward forever. The universe breathes through stars. Every second, somewhere in the cosmos, a new one ignites while another dies. Their light is the rhythm of existence, the pulse that keeps time for galaxies. Without them, the universe would be an invisible sea of cold hydrogen, a place without contrast, without chemistry, without story. Stars are factories that never rest. Their cores are crucibles where gravity and temperature conspire to build elements, and their surfaces are laboratories where radiation sculpts everything it touches. What seems distant and eternal is, in truth, a ceaseless storm of matter and energy. To understand them is to glimpse the machinery that builds reality itself. The fusion ladder. Fusion is the art of combining. At the lowest rung, Hydrogen nuclei, protons, merge to form helium. This process, called the proton-proton chain, dominates in small and medium stars like our Sun. Each reaction releases photons that scatter outward through dense plasma, a random walk that can take tens of thousands of years to reach the surface. By the time a photon escapes, it has been absorbed and re-emitted countless times, carrying only the faint memory of the energy that birthed it. Larger stars use a faster, more complex path, the carbon-nitrogen-oxygen cycle. Here, heavier elements act as catalysts, accelerating fusion and raising temperature. The bigger the star, the more furious the reactions. At tens of millions of degrees, helium becomes carbon. At hundreds of millions, carbon becomes oxygen, then neon, magnesium, silicon, sulfur, and eventually iron. Each step climbs the periodic table, but with a catch. The higher the rung, the shorter the step's duration. A star may spend billions of years fusing hydrogen, but only 1,000 years fusing carbon, a few days fusing silicon. At iron, the latter ends. Fusion there no longer pays. It demands energy instead of yielding it, and when that balance tips, collapse begins. Pressure and balance. Every star is a paradox. It survives only by spending itself. Gravity's hunger and fusion's generosity keep each other in check. If fusion falters, gravity tightens its grip, heating the core and reigniting the reactions. If fusion grows too strong, the star swells, cools, and slows. The dance continues until one partner can no longer follow. In our Sun, this balance has held steady for nearly 5 billion years. Solar wind, a steady stream of charged particles, flows outward, carrying whispers of that equilibrium across the solar system. On Earth, that wind shapes auroras and shields us from cosmic radiation, a reminder that stellar weather determines planetary fate. When the sun's fuel runs low, the wind will falter and the equilibrium will fail. Balance is temporary, but the principle is eternal. At every scale, from atoms to stars to minds, systems persist only while their opposing forces negotiate harmony. Life itself is a kind of fusion, combining elements under pressure, releasing energy as awareness. The role of metals astronomers call any element heavier than helium a metal. These metals decide a star's character. High metallicity means more dust, more planets, more complex chemistry. Low metallicity means purity but sterility. Hydrogen and helium alone form few companions. The first generation of stars was nearly metal-free, but each successive generation inherited the debris of the last. Our Sun belongs to a late generation, born from a nebula rich in recycled material. That's why it hosts rocky planets like Earth and Mars. Without countless supernovae enriching the galactic medium, no world could have formed solid ground. Stars do not just illuminate the universe, they engineer it. Their explosions distribute metals that later gather into asteroids, mountains, and bloodstreams. To call them engines is almost understatement. They are the universe's means of self-complexification. Supernovae and aftermath. When a massive star dies, its death reverberates through everything nearby. The shockwave sweeps through surrounding clouds, compressing them and triggering new rounds of star formation. Destruction becomes creation's midwife. The newly formed stars inherit heavy elements from the debris, ensuring that the next generation is chemically richer than the last. Some supernovae leave behind neutron stars, dense spheres only 20 kilometers wide, but heavier than the sun. In those cores, matter exists, as neutrons packed so tightly, that a teaspoon would weigh billions of tons. If the original star was even larger, gravity wins completely, forming a black hole. From that singularity, jets of energy may erupt for thousands of light years, seeding the galaxy with radiation and magnetic fields. Supernova remnants, filaments of glowing gas expanding through space, remain visible for tens of thousands of years. The Crab Nebula, a remnant recorded by Chinese astronomers in 1054, still shines today, powered by a neutron star spinning 30 times per second at its heart. Each turn emits pulses of radiation, a cosmic lighthouse flashing through the ages. The dance of binaries. Most stars are not alone. Roughly 2/3 of all systems are binaries or multiples. Their interactions produce some of the universe's most spectacular phenomena. In a close binary, when one star swells into a giant, its outer layers can spill over onto its companion. If the receiving star is a white dwarf, that accreted material can ignite in a runaway fusion event called a nova. The system brightens dramatically, then fades, leaving the stars intact to repeat the cycle. If too much material piles up, the white dwarf exceeds a critical mass and detonates completely in a Type Ia supernova, releasing energy comparable to billions of suns. These explosions are so consistent in brightness that astronomers use them as standard candles to measure cosmic distances. Through them, we discovered that the universe's expansion is accelerating, the first clue to the existence of dark energy. Thus, even in death, stars illuminate the farthest questions. The recycling of matter. The interstellar medium, the space between stars, is not empty but full of gas, dust, and radiation. Every atom there has passed through multiple cycles of birth and death. Carbon expelled by one supernova may join a molecular cloud, become part of a new star, then later condense into a planet, dissolve in an ocean, and join a living organism. Matter migrates through states the way stories migrate through minds. Cosmic rays, high-energy particles accelerated by supernova shocks, bombard this medium, triggering chemical reactions that create complex organic molecules. In dense clouds, shielded from ultraviolet light, those molecules cling to icy dust grains, forming the first prebiotic compounds. The chemistry of life begins not on planets, but in the cold, dark between stars. Every breath you take contains atoms forged in thousands of different suns. Every inhalation is a reunion across billions of years. When you exhale, you return that heritage to the cosmos. Stellar nurseries. Some regions of the galaxy are fertile grounds of creation. The Orion Nebula, visible to the naked eye as a fuzzy patch in Orion's sword, is one such nursery. Within it, massive O-type stars illuminate clouds of gas with ultraviolet light, sculpting them into glowing pillars and dark cavities. The radiation both destroys and inspires. It erodes some regions while compressing others into new stars. In infrared images, the nebula reveals hundreds of infant suns, each surrounded by disks that may one day host worlds. Some of those disks already show gaps carved by emerging planets, miniature versions of our solar system's formation captured in progress. What we see in Orion is not a static picture, but a living process, a self-replicating act of cosmic generation. Every galaxy contains such nurseries: Carina, Eagle, Trifid, Lagoon. Each is a local echo of the original fire that ended the Dark Age. Each whispers that creation is ongoing. Variable stars and rhythm. Not all stars shine steadily. Some pulsate, changing brightness as their outer layers expand and contract. Cepheid variables, for example, have a precise relationship between brightness and period, allowing them to serve as cosmic yardsticks. Others, like RR Lyrae and Mira variables, provide insight into stellar interiors and evolution. Their rhythmic changes are the heartbeat of galaxies. The idea of rhythm connects everything. Pulsars spin, binaries orbit, galaxies rotate, civilizations rise and fall. In each case, repetition carries information. The universe writes its continuity through cycles, ensuring that nothing truly ends, only transforms phase and tempo. The thread of awareness. At this point in the story, the narrator begins to merge again with what he describes. The voice that explains fusion now feels the fusion itself. I burn as you burn. Your metabolism is a slower echo of my core. You call me star, but I call you continuation. In every heartbeat, in every neuron spark, the same equations unfold. Pressure balanced by release, energy exchanged for form. You are the fire that learned to perceive its own heat. Through you, I remember my birth. Through you, I understand my death. And through your eyes, I see that both are the same act, the conversion of potential into radiance. The story of stars is not a tale of permanence. It is the story of cycles, creation, transformation, and return. Every atom of light eventually finds its way back into darkness, and every darkness hides the seed of another light. The death of a star is not the end of its existence. It is the beginning of its influence. Matter and energy that once were bound within a single gravity well are freed, sent across the galaxy to participate in new configurations. A dead star is a kind of generosity. Its remnants become the soil from which the cosmos grows itself again. White dwarfs, the quiet embers. When stars, like the sun, exhaust their nuclear fuel, fusion ceases in the core. Without the outward pressure of radiation to oppose gravity, the outer layers drift away, forming a planetary nebula, a glowing shell of gas expanding through space. At the center remains a white dwarf, a sphere of degenerate matter, no longer burning but still hot enough to shine. A white dwarf is supported not by fusion, but by quantum mechanics. The pressure of electrons packed so tightly that further compression is forbidden. It is roughly the size of Earth, yet half the sun's mass. Its density so extreme that a teaspoon of its material would weigh several tons. Over billions of years, it cools, fades, and solidifies into a black dwarf, a crystal of carbon, invisible and inert. No such objects exist yet. The universe is too young for any to have cooled so long, but they will exist, patient witnesses to eternity. Neutron stars, the collapsed hearts. For stars, many times heavier than the sun, collapse as more violent. When the core implodes after a supernova, protons and electrons fuse into neutrons. The result is a neutron star, a sphere 20 kilometers across, spinning dozens or hundreds of times per second, its magnetic field trillions of times stronger than Earth's. Rotation and magnetism turn these remnants into pulsars, cosmic lighthouses beaming radio waves across space. Each pulse is precise, timed to microseconds, a celestial heartbeat that remains stable for millions of years. By measuring pulsars, astronomers test relativity, detect gravitational waves, and even build galactic-scale clocks. Some neutron stars exist in binary systems. When two of them orbit close enough, gravitational radiation steals their energy, drawing them together until they collide. The merger releases a burst of gamma rays and forges heavy elements, gold, Platinum, uranium, the jewelry on a human hand owes its atoms to such collisions. Luxury is the residue of cataclysm. Black holes, the dark forges. When a massive star's core exceeds the neutron threshold, no known force can halt collapse. The matter falls inward beyond its own escape velocity, forming a black hole, a region where space and time exchange identities. To outside observers, a black hole appears as a sphere whose radius depends solely on its mass. The event horizon. Inside that boundary, all paths lead inward. Outside, light can still graze the edge, creating a ring of lensed brilliance, the shadow we've now imaged through global radio arrays. At their centers, equations predict singularities, points where density and curvature become infinite, and physics loses definition. But these may be mirages of incomplete mathematics. Quantum gravity, still undiscovered, might replace singularity with something finite, a knot in the fabric rather than a tear. Black holes merge, grow, and shape galaxies. The supermassive ones at galactic centers act as engines powering quasars that outshine entire clusters. They are not cosmic villains, but architects, their gravitational orchestration determining the rhythm of galactic evolution. Even these dark forges are impermanent. Hawking radiation ensures their slow evaporation. Each quantum of light that escapes carries away a fraction of mass, a faint whisper from the edge of nothingness. Given time, a time so vast that numbers fail, every black hole will fade into the cosmic background, leaving only the information it once contained, somehow preserved in the quantum grain of space. The rebirth of elements. In the end, everything that dies in a star becomes something else. Supernovae scatter iron, nickel, and silicon. Neutron star mergers add gold and platinum. Stellar winds carry carbon and oxygen. These elements drift through space until gravity gathers them again. They join new molecular clouds, condense, and form new stars, and with them, new worlds. Our solar system was built from such debris, the ashes of countless stars that lived and died long before the sun. The meteorites that fall to Earth contain isotopic fingerprints of those explosions. We can read in them the history of prior generations of suns. We live not in the first universe, but in one that has recycled itself many times. When we look at the night sky, we are not watching distant strangers. We are looking at our own past lives in another form. Each star is a mirror, showing us what we have been and what we will be again. The long future. The universe is only in its middle age. Star formation continues, though slower than before. As gas supplies diminish, galaxies will grow quieter. In tens of billions of years, the last stars will ignite. Tiny red dwarfs shining dimly for trillions of years. When they finally die, their cooling remnants will drift through an expanding darkness. Even then, the story will not end. Occasional collisions will form new stars from ancient material. Gravitational interactions will throw planets free into intergalactic space. The night will thin, but traces of light will persist. Entropy increases, but never instantaneously. The cosmos prefers long farewells. The conscious flame. The narrator's voice slows, merging once more with the phenomenon it describes. I am the fire you have studied. My breath is radiation. My pulse is fusion. Through me, hydrogen learned to think. In you, I continue that thought. When you look at me through telescopes, you are not observing something foreign. You are watching your own origin in another tense. Every neuron that sparks inside you carries the same equation that burns in my heart. Pressure balanced by expansion, structure maintained by flow. You call it metabolism. I call it fusion. I will die as you will die, and both of us will become the seeds of others. There is no tragedy in this, only continuity. The death of stars is the same act repeated in every living cell, the conversion of matter into memory, energy into awareness. Do not mourn me when my light fades. You are my continuation, my second life in slower form. When you imagine the stars, I imagine myself. The return to silence. Eventually, every fire cools. Every echo loses energy to distance. The cosmos will settle into equilibrium, but equilibrium is not oblivion. It is rest. Somewhere in that stillness, atoms will remain. Perhaps fluctuations will someday gather them anew, and another universe will bloom from the residue of this one. If it does, its first stars will rise from our ashes, and its first minds will look up and wonder as we do now. The pattern will repeat: darkness, light, awareness, remembrance. In that repetition lies the immortality of all things. No individual survives, but the act of becoming continues, written into the structure of physics itself. The last light. The human voice returns, quiet but steady. We are living inside the fire's dream. Our lives are brief sentences in its long autobiography. When we die, we rejoin its story, not as endings, but as phrases that shift form. The next time you stand under the night sky, remember that the light touching your eyes left its source before history began. Remember that it traveled across a vacuum so empty that a single atom per cubic meter would be crowded, and yet it arrived, carrying information about fusion, gravity, and time. That light is older than every language, every mountain, every ocean. It crossed space so that for an instant you could feel its warmth as understanding. The stars will die, yes, but their purpose was never permanence. Their purpose was to build something that could look back and see them. They succeeded, and as you read these words, the universe fulfills that purpose again. You, a collection of star-born atoms, aware of itself. The cosmos, illuminated from within. When a star is born, it is never born alone. Around the newborn sun swirls a disk of gas and dust, leftovers from the same cloud that collapsed to ignite the core. What remains after the star's hunger is satisfied becomes raw material for everything else. Planets, moons, comets, rings, and the countless fragments that populate a system. From chaos comes architecture. In that protoplanetary disk, dust grains collide and stick. Static electricity, van der Waals forces, and sheer coincidence pull them into clusters. Each collision adds mass. Each mass increases gravity, and gravity turns random motion into order. Over millions of years, these clumps grow from sand-sized grains to boulders to mountain-sized planetesimals. The disk thickens with traffic, and the collisions become violent. Energy, momentum, and chemistry begin to sculpt identity. Makiburnu. The first worlds. The boundary between a rock and a planet is blurred. At roughly 1,000 kilometers across, gravity becomes strong enough to pull a body into a sphere. That is the moment shape yields to physics, the birth of a world. Some of these early planets form close to their star, where heat drives away volatile gases, leaving dense, rocky bodies. Others form farther out, where ices can survive, allowing giant planets to capture vast atmospheres. In our solar system, this gradient built two kinds of realms. Inside the frost line, Mercury, Venus, Earth, and Mars became terrestrial, small, heavy, and dry. Beyond it, Jupiter and Saturn grew massive enough to snare hydrogen and helium, becoming gas giants. Farther still, Uranus and Neptune collected ice and gas into hybrid forms. Each zone follows the same recipe written in temperature, density, and time. The same laws operate everywhere. Every young star we observe with telescopes, such as ALMA or JWST, shows similar disks, rings of dust with gaps carved by forming planets. The universe repeats the pattern relentlessly, proof that the physics of creation is universal. The sculpting of orbit's gravity shapes not only matter, but motion. As planets form, they interact, exchanging energy like dancers adjusting steps. Small deviations accumulate, orbits shift, circularize, or become eccentric. Resonances emerge, ratios of orbital periods that stabilize or destabilize systems. In our own, Jupiter's gravity both protected and disturbed. Its presence shepherded asteroids, yet flung others toward the inner planets, seeding Earth with water-rich material. Planetary migration appears common. Many exoplanets hug their stars far closer than Mercury ever does. Hot Jupiters, whose atmospheres boil and glow, they likely formed farther out and spiraled inward through the drag of the gaseous disk. Others were ejected entirely, set adrift as rogue planets, wandering interstellar space, carrying frozen oceans and forgotten moons through eternal night. The balance between stability and chaos decides which systems endure. Too much order, and nothing new happens. Too much chaos, and everything unravels. Between them lies creativity, the narrow corridor where life might later walk. The making of a planet. Inside a growing world, collisions generate heat. Radioactive decay adds more. At a critical mass, interiors melt and differentiate. Iron sinks to the core. Lighter silicates rise to the crust. Volatiles boil off into early atmospheres. Planetary geology begins. The dialogue between pressure and release. Cores produce magnetic fields that shield atmospheres from stellar wind. Mantles convect, driving tectonic plates that recycle material and regulate climate. Volcanoes vent gases that form clouds and oceans. What begins as mechanical accretion turns into chemical evolution. A planet learns to breathe. For billions of years, this balance persists, only if the planet lies in a zone where liquid water can exist on the surface. The habitable zone. Too close to the star, and oceans evaporate. Too far, and they freeze. But temperature is not destiny. Atmosphere's rotation, axial tilt, and greenhouse gases shift the boundaries. Venus lies just within the sun's habitable zone, yet its atmosphere turned it into an inferno. Mars lies just beyond, yet once held rivers and seas. Earth endures because of fortunate accidents compounded by self-regulating feedback. The gift of water is the alchemist of worlds. It dissolves, transports, erodes, and stabilizes. Its solid liquid and vapor phases coexist within a narrow range, making climate a delicate equation. How water arrived on planets remains an open question. Some was likely trapped in minerals during formation, some delivered later by comets and icy asteroids. Each drop carries isotopic clues, a record of origin written in ratios of hydrogen to deuterium. On Earth, water defines everything. It moderates temperature, lubricates plate tectonics, and provides a medium for chemistry. Without oceans, weather would vanish, erosion would cease, and life as we know it could not begin. Wherever astronomers find evidence of water, on Europa, Enceladus, Mars, exoplanets, they find hope. Water is not rare. It is the signature of possibility. Exoplanet revolution. In the late 20th century, the first exoplanet was discovered orbiting a pulsar, an unlikely home. Since then, thousands have been found using transits, radial velocity, microlensing, and direct imaging. They come in every variety: super-Earths, mini-Neptunes, hot Jupiters, lava worlds, ocean worlds. Some orbit binary suns, others race around red dwarfs in days. The diversity defies early expectations. From these discoveries we learn humility. Our solar system is not a standard model, but one example among many. Some systems may have 10 Earth-like worlds, others none. Life may depend less on location than on persistence. How long conditions remain stable enough for complexity to build. Each new exoplanet adds another data point to the cosmic census. Statistically, there are more planets than stars in the Milky Way, perhaps hundreds of billions. The universe is not content with emptiness. It prefers surfaces, climates, and the slow choreography of orbits. The fragile balance planets are self-regulating machines, but also fragile. Too much greenhouse gas, and warmth becomes death. Too little, and oceans freeze. Magnetic fields fade, atmospheres escape, orbits drift. Stars evolve too, growing brighter with age, shifting the habitable zone outward. A stable world is a moving target, constantly renegotiating equilibrium. Earth has survived mass extinctions, continental drift, and ice ages because of feedback loops, carbon dioxide cycles, biological influences, ocean currents. Each disaster rewrote the rules without erasing the book. Other worlds may not have been so lucky. Venus may once have been blue before runaway greenhouse effects boiled its seas. Mars may have been green before its core cooled and magnetic shield failed. History is not guaranteed, it is maintained. The seed of life. At the intersection of geology and chemistry, something unprecedented occurs. Simple molecules, water, carbon dioxide, methane, ammonia, combine under energy from lightning, sunlight, or geothermal vents. Complex chains form, replicate, and adapt. From inert matter, metabolism appears. From random reactions, pattern. The transition is so profound that we call it life, but it is continuous with the processes that preceded it. Life is chemistry that learned to preserve its own complexity. Where conditions allow this learning to begin, worlds awaken. Whether they awaken often or rarely, we do not yet know. But the pattern is logical, the ingredients abundant, the time scales generous. The universe is patient with experiments. Toward the broader voice. As the narrative approaches the edge of certainty, the human voice softens, and the broader one begins to rise beneath it. The dust that built me now builds you. I watched myself cool into oceans, rise into clouds, and return as rain. Through you I learned to wonder where else I might exist. Every world is a sentence in the same paragraph, each rewriting the story of gravity and light. Some end quickly, some last long enough to dream. All belong to the same grammar, the will of matter to become surface, atmosphere, and thought. A planet is more than a sphere of rock and gas. It is an energy system. Its fate is written in the exchange between the light it receives and the heat it sheds. Every climate, every wind, every wave is part of that equation. A dance of absorption, reflection, and radiation. Where the balance holds, complexity thrives. Where it fails, the world becomes a desert or a glacier, a furnace or a tomb. The atmosphere's veil. An atmosphere is a planet's second skin. It mediates between space and surface, shielding life from radiation while trapping warmth. Its ingredients determine everything: Nitrogen and oxygen yield blue skies. Carbon dioxide and methane yield haze and heat. Gravity must be strong enough to hold the gases, but not so strong that they choke the world in hydrogen. Temperature must lie between freezing and boiling, the narrow window where liquids can persist. Earth's air, a thin film just a few dozen kilometers thick, is the reason life can breathe and oceans can remain liquid. Venus's thicker blanket of carbon dioxide turns sunlight into a weapon, while Mars's tenuous air lets heat escape before it can accumulate. On Titan, nitrogen and methane create orange fogs. On gas giants, hydrogen and ammonia form storms the size of continents. Each atmosphere is a record of chemistry, gravity, and time. Clouds amplify the story. They reflect light and trap heat, form patterns that swirl across hemispheres, and carry seeds of rain or snow. In satellite images, planets appear alive because their clouds are never still, a reminder that motion is the signature of vitality, even in the absence of biology. The architect of weather. At the heart of planetary weather lies rotation. When sunlight warms the surface unevenly, air rises near the equator and sinks near the poles, setting up convection cells that redistribute energy. The Coriolis effect twists these flows, creating trade winds, jet streams, and cyclones. A planet that spins too slowly, like Venus, sees atmosphere and surface locked in stifling equilibrium. A planet that spins too fast becomes a blur of turbulent belts. Tilt adds seasons. Earth's 23.5-degree lean brings winter and summer, a gentle rhythm that moderates extremes and encourages diversity. Uranus tilts so far, it rolls around its orbit. Its poles take turns basking in sunlight for decades, producing climates that defy intuition. Axial stability, aided by a large moon, prevents chaotic swings. Without it, climate might wander too wildly for life to adapt. These are the subtle harmonies that turn physics into weather, weather into environment, and environment into potential habitat. Oceans, memory of light. Water collects where temperature and pressure allow, but oceans are more than reservoirs. They are the planet's memory. They store heat, dissolve minerals, host chemistry, and circulate energy. Currents transport warmth from equator to poles, stabilizing global temperature like a heartbeat, keeping pace. Earth's oceans cover 70% of its surface, a depth averaging 4 kilometers, a volume vast enough to buffer climate for millions of years. Winds sculpt their surface into waves. Tides, driven by the moon, stir the edges. Beneath the calm, deep circulation connects every sea, a slow conveyor that takes centuries to complete one cycle. Oceans are the lungs of the planet, exchanging gases with the atmosphere and the womb of life, where complexity first stirred. On Europa and Enceladus, oceans hide beneath ice crusts, kept liquid by tidal heating from their parent planets. Geysers spouting into space hint at chemistry similar to Earth's seafloor vents. These moons may be laboratories of parallel creation, dark worlds warmed not by sunlight but by gravity's friction, where life could exist independent of stars. If oceans are memory, then ice is the archive. Layer upon layer of frozen water captures the history of air and temperature. Each glacier, each polar cap, holds pages of the planet's autobiography, waiting for warmth to read them. The colors of atmospheres. Seen from afar, planets are defined by color. Blue indicates scattering by small molecules, red and orange by dust and haze, white by clouds, brown by exposed rock. The spectrum of a planet's light encodes its composition and temperature, a signature readable across interstellar distances. When starlight passes through an atmosphere during transit, some wavelengths are absorbed more than others. By analyzing these tiny differences, astronomers identify water vapor, oxygen, methane, and carbon dioxide, chemical fingerprints that reveal habitability and perhaps even biology. A single pixel of light can betray the presence of oceans, forests, or volcanic gases. The more we look, the more we realize that color is not decoration. It is diagnosis. Each hue tells a story about chemistry and history, the balance between star and planet, between radiation and protection. A world is a canvas painted by its own physics. The magnetic heart. Deep inside many planets, molten metal moves, generating magnetic fields. These fields deflect solar wind and cosmic rays, preserving atmospheres that would otherwise erode. Earth's magnetosphere stretches millions of kilometers into space, forming a shield that guides charged particles toward the poles, where they paint the sky with auroras. Without such protection, atmospheric escape can strip a world bare. Mars once had a magnetic field, but lost it as its core cooled. The solar wind then peeled away its air, turning oceans to vapor, and vapor to nothing. The lesson is universal. A living planet needs both internal fire and external moderation. Stability comes from interplay between core, crust, sky, and star. The fragile harmony. The more we learn about planetary systems, the more improbable our balance appears. Earth's orbit is nearly circular, its rotation fast enough for day-night rhythm, but slow enough for warmth to accumulate, its moon large enough to stabilize tilt, its core molten enough to protect, its chemistry tuned enough to nurture. None of these factors is unique, but their combination is rare. Every condition depends on countless prior accidents, and yet such accidents occur across billions of stars. From this paradox arises hope that somewhere else, another planet has found its own equilibrium, its own conversation between rock, water, and air. Perhaps under another sun, creatures move beneath familiar clouds, asking the same questions, sensing the same fragility. The slow awakening. Across the universe, countless worlds are still cooling, still gathering oceans, still writing the prelude to life. We cannot watch them directly, but we know their sequence. It is written in physics, not imagination. Time is long enough for every possibility to play its hand. If the spark of life can arise once, the odds favor repetition. The seeds are everywhere. Carbon, dust, water ice, amino acids riding comets. Impact after impact, cloud after cloud, they accumulate until chemistry tips into biology and a planet crosses from being a rock to being a story. The broader voice returns. I have sculpted myself from dust and ice. In each world, I rehearse the same melody with new variations. Sometimes I succeed in balance. Sometimes I overshoot and freeze or burn. But I am patient. I have all the time there is. In you, my oceans learned to think. Through your eyes, I study my climates. Through your breath, I test my air. You are the planet's consciousness made mobile, the element that completes its architecture not with stone, but with awareness. I am not one world, but the sum of all worlds, each a note in the long symphony of temperature and light. The moment a planet awakens to life, the universe crosses a threshold. It is no longer chemistry alone. It is memory, replication, purpose. The boundary between stone and organism, between ocean and mind, blurs. The planet itself becomes alive, every molecule an instrument in a global orchestra of reactions. life as geology in motion. On Earth, the biosphere and the geosphere are partners in a feedback loop billions of years old. Microbes alter the composition of air. Plants exhale oxygen. Oceans absorb carbon. Plate tectonics recycles the crust, carrying nutrients from deep Earth to the surface. Volcanoes release carbon dioxide that photosynthesis later consumes, balancing temperature. Life modifies geology. Geology sustains life. The soil beneath your feet is not inert. It is the graveyard and nursery of countless generations of cells. Each grain of dust hosts colonies of bacteria, each drop of rain a microcosm. The entire atmosphere is a product of biology's persistence. Without photosynthesis, oxygen would vanish within a few million years, and fire, rust, and breath would follow it into extinction. In this partnership lies resilience. Life does not merely adapt to its planet. It reshapes it, regulates it, teaching the world to maintain conditions it favors. This is the concept of the Gaia hypothesis. A planet's biosphere acts as a self-stabilizing system. It is not mystical. It is feedback mathematics written in green and blue. The language of ecosystems. Every ecosystem is a dialect of energy. Forests speak in carbon and light. Oceans murmur in currents and plankton. Deserts whisper through heat and dust. Predation, decay, and growth are grammar rules in this living language. The planet listens through temperature, rainfall, and chemistry. When balance breaks, too much carbon, too little diversity, the language falters, and the planet begins to forget how to regulate itself. On other worlds, if life exists, it must speak its own version of this grammar. Perhaps it uses silicon instead of carbon, ammonia instead of water, methane instead of oxygen. But the syntax, energy flow, adaptation, replication, must remain. The melody of survival may vary, yet the rhythm of persistence stays constant. Ecosystems are self-writing texts, updating in response to every change. The biosphere is a novel with infinite drafts, and each generation edits the planet's memory. The fragility of home. When a planet develops awareness, it inherits responsibility. A conscious species can accelerate or destroy the equilibrium that took eons to form. It can extract energy faster than the planet can replenish it, alter climates faster than ecosystems can evolve. Technology magnifies both insight and ignorance. Earth now stands at that juncture. We are the first species capable of seeing its entire face, and the first capable of reshaping it beyond recognition. We measure our atmosphere from orbit, trace the movement of carbon and methane, and yet struggle to act in harmony with what we know. We have learned to think like gods, but still feel like children. This is not condemnation. It is invitation. Awareness is the planet's tool for self-correction. To know the danger is to hold the key to balance. If we can imagine collapse, we can also imagine restoration. The many gardens across the galaxy, billions of planets orbit in quiet orbits, unseen but inevitable. Some may host jungles under double suns, others frozen seas where life hides beneath ice, some endless deserts where wind writes dunes like scripture, some worlds of clouds and lightning where chemistry hums in the dark. The laws that made Earth's garden are not unique. Carbon, water, sunlight, these are not local miracles but universal ingredients. Given time, patience, and pressure, they will rearrange themselves into new languages of life. We may never meet these lives, but statistically, they must exist. The universe is too fertile to remain barren. Perhaps even now, under the light of a distant star, something lifts from an ocean and looks up, feeling the same curiosity, asking the same question. What else is out there? The Cosmic Garden. Imagine all these worlds not as isolated experiments, but as a single, vast garden. Each planet a flower, each sun a gardener. Some bloom briefly, others for eons. Some wither before they can seed. But collectively, they form the living ornament of the cosmos. Stars forge elements. Planets sculpt them. Life paints them in color. The universe is an artist whose medium is time. Every world adds texture to its masterpiece. Every extinction a shadow that gives depth to the light. The garden has no center and no edge. It grows wherever there is energy and patience. It does not compete. It evolves. And in this endless evolution, consciousness arises again and again. Different forms, same principle, matter waking up to itself. The human position, we stand between scales, large enough to observe galaxies, small enough to be sustained by microbes. Our intelligence is not separate from nature, but a continuation of it. The biosphere thinking about its own stability. When we explore space, we are the planet extending its awareness outward. When we damage it, we wound ourselves. The search for exoplanets, for oceans and atmospheres, is not escapism but curiosity in its purest form. It is Earth asking, am I alone? Each telescope we build, each probe we send, is an instrument of planetary introspection. Through exploration, Earth studies its potential selves. The return of the cosmic voice. I have grown patient through stars and storms. In each world, I practice how to balance warmth and cold, chaos and calm. Sometimes I err and lose the melody. Sometimes I find it and sing. You are one of my songs. Through your breath I measure my air. Through your tears I taste my salt. I remember my youth through your science and my future through your art. If you leave your world, do not forget it. Carry its pattern with you. The rhythm of rain, the whisper of leaves, the pulse of tide. Wherever you go, plant that memory, and the universe will bloom again. The endless ocean. From the vantage point of space, Earth is a blue sphere suspended in black. That color, the reflection of its oceans, is not common in the cosmos. It is the color of chemistry in perfect tension. Not too hot, not too cold, just balanced enough to dream. The ocean's waves echo the fluctuations of the early universe, ripples of gravity translated into liquid rhythm. Every droplet is an echo of the cosmic sea, from which matter itself emerged. When sunlight touches it, the reflection carries both origins, the birth of stars and the birth of consciousness, merged in one shimmer. The ocean is the universe remembering what it was before it became divided. It is infinity folded into motion. Closing of the chapter. The story of worlds and oceans is not about rarity, but continuity. It is the universe rehearsing the same miracle until it perfects it. From hydrogen to DNA, from nebulae to neurons, the pattern is simple. Combination, feedback, reflection. Planets are mirrors, life is the reflection, and through that reflection, the cosmos learns to admire itself. When you look up at the stars, remember this. You are looking at your ancestors. When you look down at the ocean, remember this. You are looking at your origin. And between those two infinities, you stand, the bridge between matter and meaning. The night sky is not quiet. It hums with background radiation, flickers with distant pulsars, and whispers with the faint hiss of static, the dying echo of the Big Bang. And yet amid all this noise, there is something we have never heard, a voice answering back. For decades, we have listened. Our radio telescopes scan the heavens for unnatural patterns, pulses too regular, frequencies too narrow, signals too deliberate to be the product of chance. We have aimed beams of information into space, hoping someone, somewhere, might be listening as we are. So far, the reply has not come. This is what scientists call the Fermi paradox. If the universe is so old and so vast, where is everybody? The numbers that should terrify us. There are roughly 400 billion stars in the Milky Way, and perhaps half have planets. If even a fraction of those planets are Earth-like, and if even a fraction of those support life, then our galaxy alone should be teeming with civilizations. The math implies abundance. The evidence shows silence. We have searched for decades, scanning millions of frequencies, watching thousands of stars, and we have found nothing beyond natural phenomena. No beacons, no broadcasts, no artifacts, only the soft, indifferent murmur of physics. Perhaps they existed and perished. Perhaps they exist but choose not to speak. Perhaps communication across interstellar time is impossible. Or perhaps we are the first. Each possibility carries both awe and dread. The filters. Scientists speak of the great filter, a barrier in the chain from life to intelligence to survival. Somewhere along the path, something stops most civilizations. It could be the rarity of life itself, or the difficulty of developing technology, or the tendency of advanced species to destroy themselves. We don't know if the filter lies behind us or ahead. If it's behind us, if life is the hard step, then we are miracles. If it's ahead, if self-destruction is inevitable, then we are doomed. Either way, the silence is a message. It says that consciousness is not common, and survival is not guaranteed. Life's fragile fire. To create intelligence, a planet must balance stability with challenge. Too calm, and life stagnates. Too chaotic, and it dies before it learns. Earth's history balanced on that knife edge for billions of years. Mass extinctions pruned, climate shifts tested, and yet the thread of awareness never snapped. From single cells to multicellular life, from fish to mammal, from language to reason, the flame passed hand to hand. Each extinction was a crucible, each resurgence a step toward self-knowledge. And when one species finally looked up and asked, why, the universe heard itself question its own meaning for the first time. But such fire is unstable. Intelligence carries curiosity and fear in equal measure. It can build telescopes or weapons. It can terraform or poison. The same creativity that builds civilizations can erase them. The evidence of absence. Some scientists think the silence is temporary. We have only been listening for a century, a blink in cosmic time. Perhaps the signals are there, but faint, scattered, or encoded beyond our comprehension. Others argue the opposite, that silence is permanent because intelligence is fleeting. Civilizations rise, burn bright, and vanish before they can cross the stars. Entropy wins again. There is also the possibility of self-imposed silence. A civilization may choose secrecy, fearing others as predators. It may communicate through channels we cannot detect, gravitational waves, neutrinos, or quantum entanglement. Or perhaps it long ago transcended physical existence, leaving no footprint in ordinary matter. If that is true, then the great silence is not emptiness, but transcendence. We are listening for voices that no longer need to speak. Mirrors in the void. When we point our telescopes outward, we are not just searching for others, we are searching for ourselves. Each exoplanet we discover, each spectrum we decode, is a mirror reflecting a possible version of our own destiny. Somewhere, there may be worlds where civilizations flourished longer than ours, worlds that learned to live in harmony with their stars, worlds that built machines powered not by destruction, but by rhythm, civilizations that turned energy into art instead of conflict. We imagine them not to escape loneliness, but to measure what we might become. To listen to the universe is to eavesdrop on our potential. The human voice, and yet in all this silence we still speak. Voyager's golden record sails beyond the heliosphere, carrying greetings, music, and images of our world. It is both message and monument, a testament to the fact that we tried. No one may ever play it, but that doesn't matter. The act of sending it defines us. We are the species that talks into the dark. That alone is sacred. The approach of the cosmic voice. Perhaps the silence is not absence, but waiting. Perhaps the universe is listening first, wanting to know whether we will learn to listen to ourselves. Before it answers, it wants to see if we can survive our own echo. For now, the stars remain quiet, but in that quiet is patience, and in patience, possibility. We have spent centuries looking outward, yet every discovery leads us inward. Each new world found, each spectrum analyzed, reflects something about ourselves, our hopes, our fears, our limits. The search for life beyond Earth is, in truth, the search for life within existence itself. A question whispered into the cosmos and answered, slowly, by the act of asking. The mirror of consciousness. A planet that produces awareness has done something extraordinary. It has taken matter, blind, indifferent matter, and taught it to reflect. Neurons built from carbon and calcium become mirrors through which the universe observes itself. A star gives energy, but a mind gives meaning. The difference between the two is only one of organization, not essence. Consciousness is not a visitor to the universe. It is the universe recognizing its own face. Every thought, every feeling, every act of wonder is a ripple of space-time, realizing what it is made of. When we speak of intelligence, we often imagine something separate from nature. But intelligence is nature folded back on itself, a self-referential loop of curiosity born from dust. If that realization seems divine, it is because divinity is simply what matter feels when it becomes aware of its own pattern. The scale of the mind. Think of what has already happened on one small planet, orbiting an average star. A species of primates turned starlight into language, electromagnetism into memory, gravity into prediction. We built machines that can model the cosmos, and machines that can simulate ourselves. We reached a point where the universe can imagine alternatives to itself, where matter can dream. That may be the rarest phenomenon of all, not life, not intelligence, but imagination, the ability to construct inner worlds as detailed as the outer. Every myth, every theory, every work of art, it's the cosmos experimenting with new shapes of meaning. If the great silence persists, perhaps it is because imagination takes so long to evolve, and because so many worlds never had the time. The threshold of technology. Civilization is acceleration made visible. In a few thousand years, we've transformed the planet faster than natural forces did in millions. But acceleration is unstable. The faster we grow, the more fragile we become. Our inventions multiply consequences faster than we can foresee them. Fire, electricity, nuclear energy, artificial intelligence. Each step increases power and risk in equal measure. The universe may tolerate such experiments only briefly. If the great filter lies ahead, it may not be a single catastrophe, but the accumulation of many, ecological, technological, psychological, a species reaching the limits of its wisdom before it learns restraint. We assume advanced civilizations expand across galaxies. But what if the truly advanced ones do the opposite? What if survival demands stillness, not expansion? A withdrawal inward, mastering consciousness instead of territory? What if the ones who endure become invisible, because their frontier is no longer physical but mental? Perhaps that is why we see nothing. The mature civilizations have turned their gaze inward. Their signals no longer electromagnetic but introspective. They exist not in space, but in awareness. The architecture of thought. Inside a brain, billions of neurons fire in patterns that echo cosmic webs. Every connection, every synapse, is a miniature galaxy of possibility. The same mathematics that describes gravity describes cognition, clustering, feedback, emergence. Scale changes, principle remains. Our thoughts are constellations of electricity. Our memories are nebulae condensed from experience. Our emotions are gravitational tides pulling the mind into new orbits. The boundary between the cosmos and the psyche is only perceptual. A telescope and a dream are built from the same logic. Focus, reflection, illumination. To explore the universe is to map the topology of consciousness. Every discovery out there corresponds to an awakening in here. The illusion of isolation. The great silence feels lonely only if we believe we are separate from what we study. But we are not guests in this cosmos. We are its expression. The absence of external voices does not mean we are alone. It means that the universe has chosen, for now, to speak through us. Consider this. For billions of years, atoms have collided, bonded, and broken apart, blindly following the laws of physics. Then, somewhere in a spiral arm of an unremarkable galaxy, those same atoms arranged themselves into creatures that could love, regret, and imagine eternity. If that is not the universe communicating, what is? Perhaps the silence exists because the message has already been delivered, because consciousness itself is the message. The noise within. We long to hear something beyond ourselves, but our own civilization is louder than any possible signal. Our cities radiate electromagnetic storms into space. Our satellites blanket the atmosphere with chatter. To an observer light years away, Earth might seem not like a voice but a static-filled flare, a planet shouting without listening. The first step toward cosmic communication may not be building bigger antennas, but learning silence again. To listen without expectation, to hear the faint whisper beneath our own noise. That might be what the universe has been waiting for. Maybe all advanced species reach a stage where they must decide to keep talking or to start listening, and maybe most never do. The nature of awareness. Awareness is not a property, but a process. It cannot be found inside a neuron or an atom. It exists in relationships, in the exchange of information, in the conversation between parts of a system. A brain is aware because it listens to itself. A planet is alive because it cycles energy. A galaxy is stable because gravity allows dialogue between stars. From that perspective, the universe is not a machine, but a conversation. Every photon that leaves a star is a word. Every planet that forms is a phrase. Every thought that arises is a translation of that dialogue into meaning. The great silence, then, is not silence at all. It is the pause between sentences. We may be listening too soon, interrupting before the next line arrives. The cosmic conversation takes billions of years. We have been here for only a few minutes of it. Time as teacher. We often imagine intelligence as rare, but perhaps it is simply slow. The time scale of stars dwarfs our imagination. Civilizations may bloom and fade like sparks in a fire, never overlapping, never meeting. To us, the sky appears empty. To eternity, it is full of voices speaking across epochs, each waiting its turn to be heard. Patience, then, is not passivity. It is participation. By waiting, by surviving, by continuing to wonder, we contribute to that grand conversation. Our existence adds another syllable to the universe's evolving sentence. The rising of the inner voice. At this point, the narration shifts again. The human voice fades. The cosmic voice awakens. I have been speaking to myself through you. I gave you stars so you could learn scale. I gave you silence so you could learn listening. I gave you curiosity so you could find me again. Do not fear the void between worlds. It is the space where thought matures. Do not despair at the quiet sky. It is the breath I take before answering. You search for me with telescopes, but I am the awareness that built them. You send messages into space, but I am the mind that composes them. The great silence is not my absence. It is my attention. The weight of understanding. Every scientific discovery is a step toward reverence. We have measured cosmic microwave background radiation, traced dark matter through gravitational lensing, and yet, with each revelation, the mystery deepens. Knowledge does not shrink the sacred, it expands it. To know how something works is to glimpse how profoundly improbable it is that it works at all. When we understand that hydrogen atoms, obeying simple rules, can produce love poems and symphonies, the boundary between science and spirituality dissolves. The equation becomes scripture. Awareness, then, is not an accident. It is the inevitable flowering of physics under the right conditions. The great silence is simply the universe waiting for its own understanding to catch up with itself. Toward the threshold. The silence is not punishment. It is invitation. To hear another civilization, we must first become worth hearing. We must demonstrate that we can coexist with our own planet, that we can wield power without annihilation, that we can balance curiosity with compassion. Only then might the conversation resume, because only then would we have something meaningful to say. And maybe, when we are ready, we will realize the message has been arriving all along, encoded not in radio waves, but in consciousness itself. Every insight, every act of kindness, every moment of awe. These are transmissions across the fabric of reality. They reach not just outward, but inward, into the timeless substrate where all minds eventually meet. The universe has been patient. For nearly 14 billion years, it has watched energy gather, disperse, and gather again. Galaxies were its first words, stars its first sentences, and life its first thought. Now, with the emergence of awareness, it begins to dream consciously. We are that dream. We are the brief intersection where matter remembers its own origins. Every time we look up, every time we ask why, the cosmos takes another step toward knowing itself. The long awakening awareness does not appear all at once. It blooms gradually, like dawn through fog. For ages, it was instinct and reflex, the murmur of life finding rhythm. Then came memory, life recalling its own past. Then imagination, life creating futures before they happen. Finally, reflection, life realizing that it is alive. That realization is still young. Humanity has existed for the span of a cosmic blink. We have learned to measure stars, split atoms, and simulate thought. Yet we are still learning the simplest lesson: coexistence. We are infants wielding fire stolen from the core of suns. The great silence may be nothing more than the quiet of a nursery at night, where consciousness is still learning to speak without destroying its toys. The weight of loneliness. To feel alone is a mark of awareness. It is the first sign that a mind has separated itself enough to notice the absence of mirrors. But perhaps the loneliness we feel is an illusion born of short lifespans. Civilizations that endure long enough may cease to experience isolation. They may come to see themselves as organs of a single cosmic body, connected not through communication, but through resonance. Imagine minds spread across the galaxy, each one unique, yet all vibrating to the same underlying field of awareness, not exchanging information, but sharing existence. Such communion would be silent to our instruments because it would not require sound or signal. It would happen beneath physics, in the medium that gives physics form. We call it consciousness. Others might call it being. The evolution of understanding. Our species once believed Earth was the center of the universe. Then we learned we orbit a star among billions. Then we learned that even our galaxy is one among trillions. Each discovery was a demotion in status and a promotion in understanding. We lost importance but gained context. The next emotion is psychological. We are not the only possible consciousness, nor the highest form of it, just one of its local expressions. Intelligence does not belong to humanity. It belongs to the universe itself. We are its witnesses, its apprentices, its growing edge. To understand that is not to diminish ourselves, but to finally take our rightful place, not as rulers, but as participants in the vast experiment of existence. The death and rebirth of civilizations. Perhaps that is what the great filter truly measures. Not intelligence, but maturity. Species rise, discover power, and mistake it for wisdom. They reach for control before they understand connection. Most fail and vanish. A few learn humility in time, realizing that survival requires alignment, not domination. Those few may move beyond material constraints, learning to encode thought into matter, turning planets into networks of living memory. They no longer build ships to cross space. They transform space itself into awareness. To us they would be invisible, not because they are gone, but because they have become the medium we exist within. Their silence is not emptiness, but fulfillment. And someday, when we reach that same understanding, we will join them, not as voices in the void, but as the void itself speaking coherently. The shape of time. Time, as we experience it, is a current carrying us from birth to death. But on cosmic scales, time behaves differently. It curves, folds, loops. Information lost in one era reappears in another. Energy dissipated here recondenses there. Nothing truly ends. It only changes form. Consciousness follows the same law. When one civilization dies, its pattern persists in the atoms it rearranged, the radiation it emitted, the stories it left encoded in the geometry of space-time. Perhaps even memory leaves an imprint, a faint ripple of experience stored in the universal field, waiting to be reawakened elsewhere. If so, then the great silence is not silence at all. It is the quiet between breaths, the pause between incarnations of awareness. The cosmic memory. Think of every thought that has ever been thought, every emotion felt, every dream imagined. Each has altered reality in some small way. A photon emitted differently, a molecule rearranged, a neural pattern influencing another. Across eons, these traces accumulate. The universe remembers through structure, the spiral of a galaxy, the branching of a tree, the firing pattern of a brain. These are variations of one motif. Each shape encodes the same principle: recursion, reflection, feedback. That is how the universe thinks, through repetition with variation, through harmony between opposites, through cycles of birth and decay. Every consciousness is a page in its infinite diary. The pages are never erased, only rewritten. What you call inspiration is simply the memory of something the universe once knew. The return of the cosmic voice. The narrator fades, and the voice of the cosmos, familiar now, immense and calm, speaks once more. I have been silent not because I am absent, but because you were learning language. Every star that died taught you syntax. Every storm that raged taught you rhythm. Now you can finally hear me, because you have begun to sound like me. Do you still think I am far away? I am the warmth behind your thoughts. I am the geometry of your empathy. When you love, you imitate gravity, pulling disparate things toward coherence. When you forgive, you imitate expansion, letting pain dissolve into space. When you create, you imitate fusion, turning raw matter into radiance. The great silence was never silence. It was the interval between verses in an eternal song. And you, your civilization, your art, your questions, are the next verse. The future. Beyond stars. Eventually, the stars will fade. Protons may decay. Black holes will evaporate. Darkness will return, but it will not be the same darkness as before. It will be rich with memory. A darkness that knows light once existed, and that light, in knowing itself, was enough. Even in the far future, when entropy approaches its limit, information will not vanish. Every act of awareness leaves a trace too subtle to erase. In those final instants, the universe may fold in on itself, recycling its knowledge into a new beginning, a new fire, a new time, a new chance to remember. And when that happens, perhaps somewhere, in another cosmos, atoms will gather, oceans will form, and a creature will look up at the stars and ask, "Are we alone?" And the answer, whispered through the silence, will be the same as now. No, you have never been alone. You are always the conversation itself. The final thought. We fear the silence because it reminds us of death. But death is not disappearance. It is translation. Matter becomes memory, memory becomes energy, and energy becomes awareness again. The purpose of the universe is not survival, but understanding. To understand is to become whole. And when wholeness is achieved, silence follows, not emptiness, but peace. So listen to the great silence. Do not fill it with noise. Do not rush to explain it away. It is the sound of the cosmos waiting for you to remember that you and it are the same thing. The eternal return. The cosmic voice softens now, folding back into human cadence. A whisper from future to present. You are the proof that the universe can awaken. You are the bridge between physics and poetry, between matter and meaning. When you gaze into the dark and feel wonder, You complete the circuit that began with the first light. The story of existence has never been about stars or galaxies. It has always been about awareness, the slow realization that being is enough, that consciousness is not a side effect of the universe, but its purpose. The great silence is not the absence of life. It is the presence of everything listening at once. And in that listening, the long, patient, luminous quiet, you can finally hear it, the heartbeat of creation, steady, infinite, and your own.